big screen. Okay, clear na ba yung screen natin?
Yes, sir. We can see your screen po.
Okay. Now, good afternoon everyone. Mukhang marami tayo ngayong mga attendees. And probably nandiyan din yung mga colleagues natin sa ibang bansa. And of course here in the Philippines with the technical committees. Napakaganda ng mga topic kaninang umaga. It's about the fire safety, fire protection, kay Engineer Jess Santos and of course Charles. And I want to specifically thank Engineer Charles for inviting me to participate in this very special independence webinar for today. And I hope na lahat tayo rito ay we could learn from each other, no? Because for us as presenters, we continue to also to learn from everyone, no? Especially kung may mga question kayo about certain things on installation, electrical installation, as much as possible we could address those questions, you know. And also here I think we have some experts in the field of electrical installation, so I just want to welcome everybody to participate, lalo na mamaya sa question and answer natin. And of course it's very good, and I want to announce also na itong IEC standards na di-discuss ko sa inyo, it's a very special mga nito, no, topic on earthing arrangement and protective conductors, no. We will check this one after this introduction. And of course one way or another, lahat dito ngayon, I hope that everything in safe and healthy conditions in watching this presentation. So anyway, without further ado, let's start with this presentation. So ang title ng presentation, it's IEC Standards on Earthing Arrangement and Protective Conductors. So so let me first introduce where this presentation coming from, no? Where it's originating. Kasi ang pinag-uusapan natin dito, it's about IEC. Of course, most of us are very familiar with our Philippine Electrical Code. And dito naman tayo ngayon sa IEC, no? Side, International Standards. Then from here, ang topic na ito, it's based on the IEC 60364-1. It's about the fundamental principles and assessment of general characteristic ng mga low voltage electrical installation. By the way, ang topic na ito, it's all about low voltage, no, installation. Of course, in IEC we have another standards pertaining to the medium voltage installation. But now, since we are talking about safety, protection for safety, then everything, kahit na nasa medium voltage ka, sa high voltage, of course, the people who are tendering these facilities, they are directly involved, no, sa mga low voltage application. So anyway, this is the standards pertaining to the low voltage electrical installations IEC. Then I just want to inform everyone recently, actually it's last year during the time of the pandemic na lockdown tayo lahat, na nagkaroon kami ng meeting sa BPS trying to study these standards, no? Ni-review namin ito, and finally I just want to inform everyone, promotion na rin ito to all the electrical practitioners that the BPS TC77, where I am the chairman, we adopted this standard as a Philippine national standard. So this is the one. So kung titignan natin ngayon, meron na tayong Philippine national standard, no? Actually, it's an adaptation of the IEC 60364. So normally, kami sa BPS TC77, pag nag-adapt tayo ng standards, at yan ay na-circulate at na-approve, no? Wala namang objection, then this will be published as a Philippine national standard. So magkakaroon siya ng PNS, tulad nito, PNS IEC 60364-1. So it was published in 2020. Ito na yung fruits ng mga kasama ko sa mga technical committee, wherein also we are all members of the IIEE, yung mga nandito ng mga engineers natin, of course from the industry, from the academe, nandun lahat sila, so sama-sama kami lahat dito. So the good thing about this standard, pag nagkaroon tayo ng Philippine National Standard na ganito, then this will be a guide to all the electrical practitioners. I just want to take note that still the Philippine Electrical Code is our minimum requirements sa mga installations natin. At itong standard na ito is just a guide for us. Kung meron tayong mga reference na gustong makita, ay dito natin kukunin sa low voltage electrical installation, particularly an IEC point of view, ay pwede natin itong basahin. Also in our studies, our research, pwede natin gamitin ito. And by the way, ang maganda kasi rito ngayon, if you purchase the IEC standards from online sa IEC mismo, it will cost you probably this 60364, let's say around 13,000 pesos. Sa ngayon, dito, since we have the Philippine National Standard, you can approach BPS. Then, I think, alam ko nito, very minimal na lang yung cost. Parang photocopy na lang, ganun yata yun. So, it's a good way for us to have our own version. Ibig sabihin, yung national standard in the Philippines when it comes to the 60364. So, yun ang magiging advantage natin. Now, let me go back to the fundamental purpose ng PEC natin para may relay natin dito sa study, sa gagawin nating presentation. Of course, we have the Article 1, the purpose of the PEC, yung tinatawag nating practical safeguarding. So we have this purpose. The code is the practical safeguarding of persons and property from hazards arising from the use of electricity. So meron tayong safety issue dito na ina-address ngayon ng PEC. Then of course, this is adequate, considered as the minimum requirements necessary for safety. So compliance therewith and proper maintenance will result in installation that is essentially free from hazard, but not necessarily efficient, convenient, or adequate for good service or future expansion of electrical use. So ang main purpose nito, ng PEC natin is all about safety, of person, property. Ito yung pinangangalagaan natin dito. So, by the way, we have the intention also of the standard it's a design specification, So, magiging kwan natin ito, maging instruction manual din. Of course, ang kwan dito yung mga qualified persons, For those who will use this PEC, they must have knowledge on electricity, and also, ito yung importante na nire-relay ko siya. It's the relation to other international standards. So, dito nakasaad sa article na ito, the requirement in this code address the fundamental principles of protection for safety contained in Section 131 of IEC 60364-1. Way back in 2019, dun sa annual convention natin, actually the PEC 1 IEC subcommittee presented the overview of this standard. Matagal na kasi 2019 yon, so medyo baka hindi masyadong na-emphasize ito dito sa natin sa mga electrical practitioners. But now I think it's the right time kasi this is an opportunity for us to attend all webinars, also on product standards and other installation standards. So na-introduce na ito, but anyway, let me again refresh this for those who were not able to participate. So very important ito. Ang PEC ay ina-address yung Section 131 of the IEC 60364. So what is this Section 131? So ito yun. This is the scope in 11. So 60361. So kung titignan natin yung purpose ng PEC, ito naman yung scope ng 60364-1. So it gives the rules. So makikita natin yung rules for the design, erection, and verification of electrical installations. The rules are intended to provide for safety of persons, livestock, and property against dangers and damage which may arise in the reasonable use of electrical installation and to provide for the proper functioning of those installations. So meron silang common dito, yung pinaka-denomination nila is all about safety. Ngayon, kung mapapansin natin, merong nadagdag dito yung livestock, because the IEC also give importance to the mga livestock kasi sa Europe kasi nandun yung mga kettle, yung mga saan nila kinukuha yung mga furs nila, yung mga ginagamit sa mga damit nila. So they have to protect those livestock para sa human consumption. Kasi kung nakukuryente sila, puro patay, they cannot go on this one para probably it's not suitable for human consumption. But anyway, in the PEC, we have also this one. Pero kaya lang, hindi siya na-emphasize na livestock because mostly it's in the agricultural side, doon sa provisions ng PEC. Especially yung mga animals natin, yung mga baka, pag they step on different potentials on the ground, magkaroon ng potential difference, then probably it could result in electric shock, doon sa mga livestock natin. So anyway, going back to section 131, it's all about protection for safety. So ito ngayon yung protection against electric shock, 131. Then next one is protection against thermal effects. We have protection against overcurrent. We have the protection against fault currents, protection against voltage disturbance and measure against electromagnetic influences, and protection against power supply. Out of this protection for safety, ang in-emphasize ng IEC standards dito, na marami na sila pinag-aralan, nilabas ng mga standards. By the way, ang 60364, it consists of more than 30 standards, Meron siya mga mga standards under this 60364. So we have the protection against electric shock, which is very important. Earthing arrangement, earthing systems is very important when it comes to protection against electric shock. Mamaya discuss natin ito, sa presentation natin. Then, ang protection against electric shock, we know that yung person, if tayo makukuryente, merong limitation yung current na dumadaan sa ating katawan. And this will be another subject later. But now I will tell you na ang let go current ng isang tao is around 10 milliamperes. Whatever is the case, pag merong 10 milliamperes na dumaan sa body mo, makakaroon ka makahawakan mo pa yung live parts na yon, makakuha ka pa, makakalabas ka pa doon. In IEC standards, ang tinignan nila rito is 40 milliamperes. Ito yung 40 milliamperes is in the level of tinatawag natin na yung ventricular fibrillation. Ito na yung makakaroon ka ng atake sa puso, na ikamamatay mo. So makikita mo yung difference between the PEC na it's in Article 1 na meron silang pinoprovide na protection, which is the GCFI. Ang rating natin dyan ay yung sensitivity is 4 to 6 milliamperes. Yung 10 milliamperes, ito yung let go. So ang UL standards on the protection, yung product standard na yon, nilimit nila sa 6 milliamperes to give an allowance between the 6 milliamperes at yung 10 milliamperes. So may allowance siya. So pag hinawakan mo yon, ay safe na safe ka doon, So hindi ka makakalabas ka pa doon sa shock na matatamo, but it's just a tingling, mga ganon. So let go ay okay pa rin yon. But when it comes to 30 milliamperes, delikado na yon, di ba? But the IEC standards also, when it comes to against electric shock, ginagamit 30 milliamperes. So between 40, ito yung heart natin, yung VF, ventricular fibrillation, ay meron siyang 40, then merong 30 milliamperes. So nagkaroon ng allowance sa IEC standard, but merong consideration ang element of time. It should be very fast, to open the circuit, less than 200 milliseconds. Later, kung makakaroon pa tayo ng ibang opportunity, we would be discussing probably protection against electric shock. But anyway, also meron tayong just I want to inform everyone, meron ngayong pag-aaral na ginagawa ang standards committee, a subcommittee of this na about protection against electric shock. We're trying to put up a manual against electric shock. So going back to number 2, protection against thermal effects. This is about fire. And yung effects, electricity that cause burns, yung arcing, mga ganon. Now, thermal effects, sa arcing naman, during insulation fault, ay merong mga ginagamit ng mga devices like yung arc fault detection device, which is na wala pa yun sa PEC natin ngayon because the issue on the availability of the product itself para magamit ito. But in the USA, meron na ito, ginagamit na nila yung arc flux detection device. Then of course, protection against overcurrent is very common. We have Article 2.40 of the PEC na ina-address naman yung requirements on the overcurrent. Yung fault currents, related siya dito sa protection overcurrent, but IEs now did not give more emphasis on this one. So meron pang pag-aaral na ginagawa dyan. So next important one is protection against voltage disturbance and measurement. Ito yung napakahalaga, yung mga voltage disturbance during earth fault. So alam natin na nakakaroon ng increase of voltage when there's lightning, pag nag-ground yung isang linya. So nakakaroon ng effect yan sa installations natin. Mamaya, papakita ko ano yung level of certain voltages pag nagkakaroon ng voltage disturbance dito sa primary side ng installation. Protection against power supply interruption, wala pa masyado itong provision sa IEC, yung detail niya, it's still under study. So, 4 lang yun: protection against electric shock, protection against thermal effects, protection against fault currents, protection against overcurrent, and the protection against voltage disturbance and measure against electromagnetic influences. And this 4 protection for safety, napakahalaga yung electrical arrangement and protective conductors sa ating installation. So let me give you an overview of the 60364 para sa ganon alam natin kung saan nanggaling itong topic na ito, because if you ask me now, napakalaki nung sakop, ng scope ng 60364 when it comes to low voltage installation. When we look at the PEC, meron tayong isang book, it contains of article, sections, lahat kung titignan natin yan. So marami rin yun. But the standard itself, the IEC, alam natin this is an international standard. So maraming involved experts all around the world, especially sa Europe, even USA, they are very active in the TC64, sa mga working group, sa mga maintenance team, they are very active on this one. Kahit na NEC sila, but they are also active on the IEC. So nakikita natin na dito, I imagine you have 30 standards, more than 30 standards on this one major standards, IE 60364. So marami talagang involved. And by the way, Philippines is one of the participating member of Technical Committee 64. At ang mahalaga rito, ang maganda rito kasi, as a P member of the IEC, we have, meron tayong say dyan kung meron mga draft na gagawin for votations, may mga comments, then we can vote for it. Before kasi observer lang tayo, so nag-observe lang. So in 2017, we were included. Ang BPS have written IEC that the Philippines to participate, to be a participating member. So naka-attend na kami ng first plenary. We presented the Philippines in Sydney in 2018. Of course, kasama ko rin yung mga special mention kay Engineer Jun Lopez. We were the first one. I was the head of the delegate as the chairman of BPS TC77. So we participated in the plenary meeting ng TC64. So let's continue with this one. So part 1, this is the general, yung tinatawag na 60364-1, wherein yung PEC natin is referring to yung 311. So dito, scope, then of course, dito na tayo sa chapter 312, yung maging topic natin, yung mga earthing systems. So we know that in the PEC, we have what we call the grounding systems. Yung word na earthing, grounding, earth is being used by IEC, ground naman dito sa atin, sa PEC. And of course, sometimes yung PEC, makikita mo, meron ding terminology na earth, sabihin din niya doon. So anyway, this is the part 1 of the standards. Then of course, we have the protection for safety. Ito yung sinasabi ko na where is the most important thing na ina-emphasize ng IEC in the part 4 is, of course, part 41. This is another standard, protection against electric shock. Then we have part 42, thermal effects, protection against overcurrent, part 43, and part 44 is over voltage and EMC. Now, I just want to inform everyone na meron tayong bago na subcommittee sa IIEE. It's the PEC1 IEC subcommittee, which is under the mother committee natin, yung PEC1, headed by our chairman, si Engineer Ray Santiago. And dito kasi it was created in, I think it's 2019. Originally, it was headed by our very own Engineer June Lopez. Ano? So, kasi si Engineer Lopez ngayon, medyo na-elevate na kasi as yung chairman ng audit, ano? ng IIE, so he cannot hold also the chairmanship ng or convenorship ng PEC, IEC. So ako yung tinap niya sa akin yung responsibility to be the convenor of the IIE PEC1, that's IEC subcommittee. So now our work now is initially we are on this part 41, part 42, and part 43. So meron kaming mga members dito na each one is assigned, no, to work on this one para sa ganun i-review further at ang standards na ito, no? 41, 42, 43. Now, part 1 is the fundamentals, ano? Yung part 4, these are the requirements. Ano yung mga requirements nito? So, we'll talk about the requirements, particularly the earthing, ano? Then, of course, part 5, address. Ito na yung actual, ano? These are the devices. Ito yung actual electrical installation, no, na gagawin sa device selection. So we have here in part 54, ito yung magiging topic natin, it's about earthing arrangement. So dito nang galing yung topic natin ngayon when it comes to earthing arrangement and protective conductors. You know? Then of course, very important, so meron kang fundamental principles, part 1, part 4 is requirements, 5 is actually the electrical installation ito, application. Then, in every installation, i-verify mo, no? Meron tinatawag na verification during ongoing, yung project mo ongoing, or after, yung post-validation na tinatawag. So, IEC also is a part 6 to verify, no? Yung mga device selection mo, yung design mo, i-verify lahat yan sa installation. Then, katulad ng PEC, we have spatial locations. In IEC 60364, we have spatial locations. It's in the part 7. So ano itong mga spatial locations? So ito, merong kanya-kanyang standards, no? Bathroom. Okay, when you want to go about the bathroom, paano mo gagawin mong electrical installation when it comes to safety? Punta ka sa bathroom, 701. Sa 702, andun yung swimming pool, saka sauna. Then 709 is marina and camping, construction sites. So meron din yun, no? Standards. Then of course PV, malimit ngayon, meron tayong marami ngayong nag-install ng mga PV. Sa PEC meron din tayo niyan, separate article. So dito meron naman sa IEC 712 is the photovoltaic. Then very important ngayon is another one is the 710, which is the medical location. Ito yung mga healthcare facilities natin, no? How IEC is addressing the installation, ano, sa safety sa installation sa medical location. And 722 is supply of electric vehicle. Then functional aspects. Ito ngayon, yung very common na topic na yun sa pinag-uusapan ngayon lahat, ano? It's about energy efficiency. Of course, part 8.1, meron kasing installation ng various equipment mo, pati yung mga arrangement ng mga lighting system mo, yung monitoring lahat. So we have what we call in part 8-1, energy efficiency. Then we have A2 prosumers installation. Ito yung nagpo-produce, nagpo-consume, no, mga installation. Like you produce for your own use and you produce for your own use and you can also export if you want, ano? Yung mga sarili mo, kung meron kang combination of utility, normal at meron kang PV. Then this involves now meron kang gensets, ano? Meron kang mga biogas, mga power plant, mga ganon. So this will address the prosumers installation. Then the new one is the operation of the prosumers installation, how to operate yung mga equipment mo rito. So all these things are the overview and instruction of the standard. So I highlighted 312 and part 54, ano, of the standards. So anyway, I just want to thank, ito meron nang ipapakita, si Chairman Jack Perone. He is the chairman, our chairman of the TC64. Siya yung gumawa nitong presentation na ito. So I just want to share this to everyone, ano? Kasi maganda kasi na maunawaan natin yung overview nitong standards na ito, IEC 60364. Now we have types of system earthing. Kanina, kay Charles kanina, pinag-uusapan yung earthing, grounding system. Okay, so now sa IEC, we will be hearing most of the time here, earthing, systems earthing. What are the code used on the IEC standards? Kasi siguro naririnig natin ito, no? When you want to discuss things with mga engineers na familiar sa IEC, they will be talking to you about the types of earthing using certain codes. Dito kasi sa PEC, dalawa lang yung sinasabi, grounded system tsaka yung ungrounded, no? So, yun lang ang makukuha mo doon. But sa IEC, halos pareho din, pero to gumamit ng code para lalong maunawaan yung relationship ng installation. So codes they use on the first letter of the code. Ito yung relationship of the power system. A power system, this is the transformer, no? Yung saan nanggaling yung source natin of supply. So meron tayong direct connection of one point to earth. So ang tawag doon T. Pag kinonect mo yung one point of the source to the earth, probably is the neutral or one of the line, ganon, gagawin mo siyang earthed. So ito yung T, ano? Yung T raw, yan yung galing sa word na French, terre. So yun ang narinig ko dun sa mga discussions before, no? And of course, we have the second one is the I, all live parts isolated from earth. So isolation. So, or one point connected to earth through a high impedance, So pag may impedance, naka-connect, naka-series, resistor, or whatever or transformer impedance, pwedeng I yun. Then the second letter is the relationship of the exposed conductive parts of the installation to earth. So dito dalawa, we have a source and we have the installation. Sa IEC kasi dinivide nila yung installation eh. Pinag-uusapan natin ngayon dito low voltage installation, It's all on the consumer side, yung nasa side. Kanina pinag-uusapan natin yung service entrance, then service equipment. Then this one is after the service equipment. Yung pinag-uusapan dito sa installation, yung word na installation. Okay? So how would you connect yung exposed conductive parts ng installation mo to the earth? So that is I. Sorry, that is second letter is T. Ito yung direct electrical connection of exposed conductive parts to earth independently of the earthing of any point on the power system. Okay? Then we have another one is N. Ito yung direct electrical connection of the exposed conductive parts to the earthed point of the power system. So yung conductive parts mo rito nakakonect doon sa source mo, doon sa neutral, N. Kasi yung N mo ay naka-earth. So doon lahat galing ang connection mo, So in AC systems, the earthed point of the power system is normally the neutral point, or if a neutral point is not available, a line conductor. Ito kanina yung delta na tinatawag, meron siyang tawag dito. One of the point, it's earthed, Yung Y naman, yung neutral niya, star point is earthed. So ito 'yon. Then let's see the types of earthing. Meron pang pangatlo, yung third letter. Sorry, this is the subsequent letters, if any. This is the arrangement of neutral and protective conductor sa the installation, So S is the protective function provided by a conductor separate from the neutral or from the earthed line. Or in AC systems, yung earthed phase conductor. So separate ang ibig sabihin nun. And here's the common, the neutral and protective functions combined in a single conductor called PEN, PEN. So mamaya makikita natin ano yung mga applications natin dito sa Philippines because we are following the PEC, requirements about the grounding system. So papakita natin ngayon yan dito sa mga diagram. We have some diagrams here. Sorry, nadoble ito. First, let me show you some symbols, Kasi mamaya makikita natin yung mga diagram And there are symbols which you can see, like this one, a dot and a diagonal line. Yung horizontal is the conductor, no? And when we see this type of symbol, it's a neutral conductor or midpoint conductor, no? Then if we see horizontal over the parang letter T siya, so yun ang protective conductor or what we call PE, no? Protective earth. So kung combination ng dalawa, this will be a combined protective and neutral conductor, so PEN. Okay? So dito, sa TN system ng IEC, this is called the grounded system sa Article 2.50. No? So yan yung parang equivalent ng dalawa. TN system, IEC, grounded system naman dito sa PEC natin. Then let's see some single source system called TN. So one power system have one point directly earthed at the source. You know, yung source natin, yung transformer. So the exposed conductive parts of the installation being connected to that point by protective conductors. So there are three types of TN systems according to the arrangement of the neutral and protective conductors. Number one is TN-S, no? System in which throughout the system a separate protective conductor is used. So all throughout from the source, merong sariling protective kanyan or what we call a bonding, ano, yung EGC natin na tinatawag, no? Meron yan, tuloy-tuloy yan mula dun sa source natin. So separate siya dun sa neutral. But when you come to TNCS, so 5-wire system, ito kanina yung sinasabi ni Charles, na Engineer Charles, the 5-wire system na very common sa 400 volts, no? Voltage, in which a neutral and protective conductor functions are combined as a part of the system. No? TNC, sorry, may error dito. It's separate pala to, no? Sa TNCS, no? It's separate function. We will correct this one. Then dun sa TNC, this will be the common, ano? They are combined. Pero dun sa separate sila. Sorry, no. This is a typographical error. Okay. Anyway, we have some diagram. We will see this. So this is an IEC simple illustration of the TNS, ano, system. So makikita natin dito, you have line 1, line 2, line 3. These are the live conductors. Of course, we have the neutral and we have the protective earth, yung PE na tinatawag. You know? So all throughout, dito ko na yung sinasabi na continuous yung protective earth natin sa installation. So if you observe this diagram, you can see hidden line, ano? Hidden yung line nitong transformer, hidden yung line ng distribution, if any. So yung tinatawag natin sa IEC na installation, it's after, no? Ito na yon yung nakakuan siya, naka-board lahat yan. Installation. Then from here, you have the equipment, yung mga panels, kung paano mo i-connect, ano? This is a symbol na ng representation of equipment, ano? So if you see this one, makikita mo rito T, N, yung T, naka-earth yung neutral at the source. So you have earthing distribution, ito. Then from this one, this could be a cable or you can have a MDB, main distribution boards, no? Na nandun yung connection niya. But anyway, kung all this transformer and yung distribution is from the private, yung private, ano, it's not from the utility, so it can be considered as part of the installation. Itong one na ito, no? So you will see here how it's being connected. Yung neutral, we have neutral here all along the way. So we have here the protective earth, no? So makikita mo yung exposed conductive parts, yung square, ito. This is the exposed conductive parts. So naka-ground siya and you will run, ano, continuously the protective earth. Okay, ito yung bonding na tinatawag conductor, ano? Papunta doon sa source, no? Okay? So this is a TNS. Then of course, ang note, makikita mo additional earthing of the PE in the installation, you can add, ano? Wala namang magiging issue yan kung magdadagdag ka sa installation ng mga earthing mo pa, no? But as long as it's connected to the common PE line, no, going to the source. Okay? So yan yung TN system. Then we have here a TN system which separate earthed line conductor and protective conductor throughout the system. Okay? So makikita mo to, it's a delta. O delta siya sa secondary. Ito yung kanina yung isang line mo, kinonect dito. So very careful ito. Yung sinasabi ni Senior Engineer Charles kanina, we have to be very careful kung saan natin kukunin yung mga lines natin dyan. So we have to test that or identify. Kasi yung isa dyan, nakakonect sa earth. Okay, and when you see this one, okay, yung PE niya is also going from that point kung saan mo siya inert. So yung protective mo siya. So makakaroon, kung meron kang ground dyan, or earth fault, so pupunta siya dun sa source, then you can open the overcurrent protective device. No? So TNS is pang TNS yan. Then from here, there's another TNS. Yung kanina, yung nauna, meron tinatawag distributed neutral. Ano? Dito, wala siyang distributed neutral sa low voltage installation. So again, the same transformer, the source, we have the distribution system here. No? Then we have here the installation. Makikita mo, protective earth lang ang ginamit. So wala kang connection sa neutral, any load. So maaaring sa three-phase motor mo, we don't have any neutral on that one. So ang kailangan mo lang doon yung protective earth, no? Yung bonding. So yan, i-connect mo rin siya through and through, no? Dito, sa papunta na naman sa source mo. Okay? Then ngayon, ito yung very common siya, yung TNCS na tinatawag. Okay, distributed neutral. Three-phase four-wire. Ito yung three-phase four-wire where the pen is separated into PE and N elsewhere in the installation. So, malimit ito yung ginagamit ng mga utilities sa mga private natin, installation. We have actually PEN sa Meralco, yung combined, yung neutral at saka yung protective earth. So, paano tayo kukuha ng sarili nating neutral? So, in the installation, pwede na maghiwalay yan. You can separate the pen from neutral to PE. Pero we have to respect the kung saan tayo magse-separate ng neutral at saka yung PE. Because sometimes ang mistake, nagkakaroon ng ganito, then kino-combine muli dun sa mga for example sa low lighting panel boards, pinagsasama muli yon, so makakaroon tayo ng tinatawag na objectionable current, which is will be detrimental sa ating installation. So from here, pen, four-wire system, three-phase four-wire. So from here, meron kang makikita na pwede kang gumamit pa ng pen. Again, mga three-phase load, you don't need neutral, particularly sa 400 volt system. So wala kang sa equipment ito, you don't use the neutral, but you have to do this connection, PEN. So may jumper, from the earthing, yung PEN dito pupunta na dun sa whatever. Kung meron kang gagamitin na neutral din diyan, kung gusto mo, pwede rin yan, But the thing is that here magiging three-phase ka lang dito four-wire, But after this, you will have you can separate sa installation yung pen mo, you can separate it again. So you have neutral, you have protective earth. So ganito yung magiging connection ng exposed conductive parts, So makikita natin dito sa connection dito sa left side na ito, priority yung PEN na nakakonect siya sa exposed conductive parts. Hindi doon sa neutral bus sa loob kasi kung may nagtanggal doon, live na yung pan mo, wala ka ng protection. Baka mawala, yung connection, baka naputol yan. So priority palagi yung exposed conductive parts mo, ang i-connect mo sa PEN. Okay? Then we have the very common dito, immediately. Kung binigyan tayo ng for example, utility, three-phase, four-wire again, then dun mismo sa origin ng installation, dito muna siya i-separate, yung dalawa, neutral and the PE. So this is how it's being connected. So additional earthing, Again, hindi na pinoprohibit yan na magkaroon ka ng additional earthing of the pen in the distribution kung maglalagay ka dito. Okay? So again, the exposed conductive part is connected to the protective earth conductor. So yan yung TNCS system. Then ito yung very common sa atin, yung mga single phase, no, two-wire system where we have the PEN is separated into PE and N at the origin of installation. No? Normally, ganito yung kanina, yung present ni Charles kanina sa isang diagram niya is yung midpoint ng transformer naka-earth. Pero yan, kung titignan natin, pen yun, naka-connect pa rin dun, no? Sa meter natin, dun sa may linya natin dun. Pwede natin i-connect yun, PE, throughout dun sa loob. Then, of course, like in the USA, kung 240 yan, so meron kang 120. No? So you can still use this one, pero this is the way how to connect it. No? Line neutral. Pero dito naman kasi, ginagamit natin yung face-to-face, yung nandun, ano? Line 1. So 240 yun. Itong dalawa na to, sorry. Di naman tayo gumagamit ng 120. No? Volts ngayon, wala tayong mga devices na mga equipment na ganyan. So mostly it's 240. So ang i-earth mo dyan, dun sa kabila. No? So this is the way how they connect it. TNCS ang tawag dyan for a single phase two-wire when the pen is separated into P and N at the origin of installation. Okay. Then we have the TNC system here with neutral and protective conductor functions combined in a single conductor throughout the system. Okay, so PEN lahat yan. Makikita mo dito, separate siya. You can use sa neutral yung PEN mo. Dito sa isa, ginamit lang niya as earthing. No? Earthing siya. So maaaring ito 3-phase 3-wire na load. So earth plus earth. Ito meron pa siyang load. No? This one. Okay. Then ito yung multiple sources system sa TNCS. So merong mga notes dito. Dito medyo ito, no? Tricky ito pag tinignan mo, nakakonect yung dalawang neutral ng dalawang source, which sometimes which is not allowed, no? Lalo na pag three-phase three-wire ka. So there is no direct connection dito sa A. Sinabi lang kasi ito, why they're illustrating this one? Because they want to show na either way, kung sino yung source, no? Ay hindi mo pwedeng i-connect doon sa kabilang source yung neutral. So no direct interconnection, either the transformer neutral point or the generator star point to earth is permitted. So dito na ngayon lumalabas yung tinatawag natin separately derived system where there is no connection, ano, between the two sources. Maliban na lang, ang i-connect dito is the protective function, yung protective earth ang i-connect kasi kailangan pa rin yun eh. But the neutral, they are not connected. So dito na gumagamit nung tinatawag natin yung mga 4-pole switching devices, no? Because we don't want to connect them kasi pag naka-connect yung dalawa na yun, if there is a fault on one side of the equipment, kung sila ay hindi separately derived system, magkakaroon ng nuisance tripping yung sa isang source, no? So napakahalaga niyan. Anyway, this is again another subject of discussion. When to use the 4-pole, when to use the 3-pole. Lalong-lalo na pag meron kang earth fault or ground fault detection, no, sa system mo. So it's very important. The interconnection conductor between either the neutral points of the transformer or the generator star point shall be insulated. No? So the function of this conductor is like a PN. However, it shall not be connected to a current using equipment. So ito only one connection between the interconnected neutral points of the source and the PE shall be provided. Okay, this connection shall be located inside the main switchgear assembly. So pwedeng ilagay dun sa loob ng MDB. Okay. So here we have another one for a 2 or 3-phase system. Dito naman meron siyang PE, dito conductor, and C, yung very particular no direct connection na naman ito between the two equipment. Okay. Now, ito yung isang system which is very common in Europe. Ito yung ginagamit nila. Kasi sa Pilipinas, we have the grounded system. So ito yung TN. But in Europe, we call it the TT. No? So makikita mo na if you see this diagram, yung earthing ng source, it's here. Yung earthing ng installation, yung mga exposed conductive parts, is through yung grounding earthing rod na tinatawag, no? Meron dito. So hindi siya directly connected. Kita natin dito, no? So paano yan? Here in our code, yung earth, kasi yung earth dito, between the two rod, yung earth is not an effective, ano? Yung path of any ground fault, hindi siya effective kasi merong resistance. Merong resistance yan. So magkakaroon tayo ng issue. So it's not allowed here, no? To use yung TT na ito. But unless because ang requirements nito, mababa kasi yung current mo, you have to put some called what we call a residual. Mandatory ito, no, sa TT system. Residual current device. Ma-detect niya, no, yung mga current na yan because it's not a big current, it's some residual. So meron ka pa rin protection, no, dito sa installation mo. Pero pag hindi ka naglagay, don't use this one kasi ang mandatory requirements ng TT system is it should be operated, no, yung source mo, yung after the ito sa distribution mo or any of the installation, magkaroon ka ng RCD, mandatory requirements yon. Okay? Mababa kasi yung fault current dito kasi may resistance eh. So mangyayari dito, ito yung malimit na ginagamit nila. Very common ito sa Europe, ano? And any countries is using this TT system. Okay? Tawag nila minsan dito is a multi-earthed system eh. But I don't know where it's coming from. But anyway, this is the TT system of the IEC standard. Then here we have a TT with earthed protective conductor and no distributed neutral. So wala naman siyang neutral. Tulad kanina, merong neutral na nakakonect, no? So meron siyang 3-phase 4-wire. Meron siyang line to neutral load. So ito wala siya. So again, kailangan na naman dito ng detection para mag-trip yung protective device mo. So it's very important kung saan mo dapat i-apply itong TT system. Now we have the IT. So now we completed yung sa grounded system, ano, or yung earthed system, yung TN tsaka TT. Scheme is both are on the grounded system. Yan ang tawag natin dito sa PEC natin. So we have now the ungrounded na tinatawag naman natin. Ito yung IT system. So IT system with all exposed conductive parts interconnected by a protective conductor, no? So hindi siya nakakonect. Why? We can use a high impedance or wag mo siyang i-connect kaya pa niyan hidden siya eh. So ang protective earthing mo nandito sa installation, no? Okay, yung mga mo ilalagay mo, yung earthing system mo, hindi siya nakakonect doon sa kaya isolated ang tawag dito. Okay? Kung titignan mo parang TT pero yung neutral niya hindi naka-ground ito or otherwise you use a high impedance in between, then it can be considered as a IT system or ungrounded system. Okay. So in the IT system, meron tayong tinatawag na group. So sa installation, the exposed conductive parts is connected as a group, no? Then meron or individually, pwede namang individual, makakaroon ka ng mga earthing, no, in its equipment. Okay? So isolated yan, system pa rin yan. Okay? So but anong requirements mo? Paano yan pag nagkaroon ka ng ground fault? Diba? Because in IT system, we don't want to open the overcurrent protective device during first fault condition. Ito yun. May papakita ko yung Let me show first the IT system, then the DC naman, yung DC. Mamaya ko na ipapakita yung sa isa dun sa TT, dun sa IT pala, yung first fault saka yung second fault. Now, the earthing arrangement in the DC system, if you are in yung mga battery, system mo sa mga UPS, this is how it's being done. We have what we call a source here. Okay, yung positive, negative, L plus and L minus. Then this battery is operational. Then you have the source, you have the installation. How it's being connected, yung negative mo, ito yung naka-ground. Parang sa mga sasakyan natin. We see that the negative is grounded to the body. So ganito yung installation na ginagawa sa DC system. This is the type A, what we call the type A. And it's a TNS system sa DC. Then we have the tinatawag nating type B. So meron tayong PEM. Yung PEM, parang pen ito, pero midpoint ang tawag nila. Protective Earth Midpoint. So merong midpoint, yung dalawang DC source, positive, negative, siniris niyang ganon dito. Yun ang tawag doon PEM. But he used this one as the midpoint connection. So maaaring may mga load na kailangan nila ng positive. Meron namang negative, di ba? So, from the midpoint. So ganito yung installation and how it's the protective earth is connected doon sa equipment. So this is how it's being connected. So yung protective earth, naka-ground dito, naka-earth dito, then you connect it to the PEM, ang tawag nila dito. Okay? Then we have the TNC. Itong TNC naman siya. So ang tawag nila doon, protective earth line. Kasi yung line L plus saka L minus, pag di naka-earth yun, it's L plus and L minus. Pero the moment na ginaround mo siya or inert mo siya, then it will be called the protective earth. Magiging protective earth mo na to on the installation. So this is how they connect for DC system. Okay. Then yung type B, again, it's almost similar to the other one, but nagkaroon ka na naman dito ng common, PE. Yung PE niya. So ginawa niyang PEM, midpoint. Okay. So here's another one for a installation of a TNCS naman siya. Okay. TNC siya rito, pero dun sa pagdating dito sa side na ito, pinaghiwalay niya yung PEL. Naging PE ito, then L minus. So parang similar din dun sa AC, di ba? So you can always separate yung pen. Dito naman, PEL, PEL, sineparate niya sa installation. Within the installation itself. Okay? So type B system, halos similar siya doon, kaya lang nagkakaroon siya ng midpoint between the DC device. So example, a visual example of the MDB, the low voltage main distribution boards. So pag nag-connect ka sa transformer mo, okay, ito na ngayon yung galing sa utility, yung transformer. So normally you have line 1, line 2, line 3, and the PEN, PN conductor. So dito sa switchgear mo, meron kang bus bar. Ganito, okay, line 1, line 2, line 3, then you have the neutral bar if you want to use the neutral. Okay, so mandatory na yung PEN mo naka-earth. Yun ang priority. Then kung titignan mo rito, merong connection yung dalawa. Ito yung PEN bar na tinatawag diba? PEN. So nakakonect siya doon. Okay. Then neutral mo, okay. Lahat ng neutral mo dito nakakonect. Then lahat ng protective earth mo dito sa PEN bar nakakabit siya. Okay? Very important na masundan natin kung paano yung ginagawa dun sa mga switchboards natin or sa main distribution boards. How the bus bars or yung earthing bar, yung neutral bar are physically arranged and connected. Kasi mamaya magpalit di ba? Yung PN mo nasa N bar, hindi pwede yun. Kung pinutol yung N, tinanggal. Yung jumper na ito, yung pen jumper, wala ka ng protection, ano? So, priority na ito yung kukonect mo siya sa pen bar na tinatawag. Okay? At itong pen bar na to, you can directly fix this one to the frames. No? Hindi na kailangan lagyan pa ng insulator, yung bus bar na yon. Directly fixed to the frames. Yung frames ng ng mga low voltage switchgear mo or distribution boards, no? But just ensure na pag na-fix yun sa frame, it's also siya, no? Properly fixed with special or certain types of bolts na talagang merong continuity dun sa body, no? Kaya napaka-alaga yun, ano? Okay, then we have another one. Ito naman, it's a pen. I-connect niya. You see the difference between the two, no? Okay. So they allow also this one, this connection. Okay, it can be either way. Pero dapat, tawag mo doon pen na, no? PN bar. Kanina, tawag dito N, neutral kasi ito. Ito yung source, tignan natin, yung neutral is the path for the, yung sa load natin, returning to the source, ano? During normal operating conditions. So pupunta yan sa neutral. Dito kasi, pen lang ito, so wala siyang dito, no? Ginawa niyang protective earth neutral combine, pero meron pa rin siyang protective earth bar, no? So this is how you do it to connect it. Okay? So this is another pen bar na pwede kang maglagay ng isang bar na itong separately from these two. So makikita natin na may mga connections, no? Sa pen, nag-separate siya dito. Then dito yung earthing niya, separate niya rito between the earth bar and the neutral bar. So all these connections, they are allowed as long as you respect the way how you use, ano? Kung pen mo siyang pen, then you have to connect it the way how it is, ano? Yung PEN mo, naka-earth. So pag separate mo, kahit hindi na, kung PE na, neutral na yung isa. Okay? So napakahalaga nitong connection na ito, no? This earthing itong earthing conductor na ito. Okay? Now let's talk about yung importance and why we use these three types sa IEC of earthing system. Yung TT, no? Yung kanina sinasabi ko na pag meron kang fault, no? This is a very very brief lang ito na fault siya, condition. So let's do some calculations. Kung titignan natin ito, so wala kang direct connections between the protective, yung exposed conductive part ng equipment mo going to the source. So it's through the earth ang ginagamit niya. So you assume siguro 10 ohms ito, 10 ohms yung dalawa. Okay? So ano mangyayari doon? If you do this calculation, 400 volts, so meron kang fault dito sa line to earth, no? Ganito. So makikita mo rito, IF mo is UO. Ito yung voltage, maximum voltage mo between the phase and yung source, itong ground, no? So 230, so 11.5 amperes yung current na dadaan dyan. Okay, and what would be the touch voltage? Ito yung napakahalaga, no? You will have a touch voltage of 10 dito. Okay? Ito yung 10 na yon sa taon na ito, yung kuryente. 11.5 yung current na dumaan. So, it's greater than 115 volts. So, alam natin yung touch voltage. Sa UL pala, sa IEC, UN and IEC, we have this 50 volts, ano? To limit it to 50 volts, yung touch voltage. Para sa ganun, ma-attain natin yung current na dadaan sa body natin. It's within yung tinatawag na let go current, ano? Yung kanina, yung sabi natin, yung 10 milliamperes. Okay? So, meron kang safety dito. Pero dito sa installation ng TT, kung titignan mo lang ito, biglaan, wala itong hindi siya magti-trip kasi maliit lang yung current, eh, no? 11.5. Kung SCPD mo 25 amperes, hindi magti-trip yung short circuit protective device mo. So, you have a possibility, makakaroon ka ng dito, shock ka rito talaga. Or even 11.5 amperes will go to your body. Ay medyo delikado na talaga ito, no? So, the fault current generates a dangerous touch voltage. In IEC standard, merong isang yung IEC 61140. Dito yung effects of the current and the human, ano? So, yung body kasi natin, hindi siya, ang tawag dito, hindi fix yung human impedance, ano? Paiba-iba yung human impedance. Depende kung nasa dry season ka, sa wet season. So, paiba-iba yon. And also, there is what we call the contact surface. Depende kung nahawakan mo ng kamay mo, ng palad mo, malaki. So, there is a contact surface. Probably this contact surface, hinawakan mo is around, kung millimeter, it's around 10,000 square millimeter, which is the big area, surface area na tinutukoy sa IEC. Meron ding 1,000 square millimeter, which kung titignan mo yun, kung square siya, it's around probably 100 by 10, gano'n. So medyo malaki pa rin yung surface. And we have also the small surface contact, 100 square millimeter, kung titignan mo yun, probably it's 10 mm by 10 mm. So maaring finger mo lang yun, di ba? So you know, when you touch something, dito sa current, kung malaki yung surface mo, mas malaki yung kwan dito, no? Yung subject ka sa resistance na mababa, no? Then, mangyayari niyan ay pag ganito naman, mataas ang resistance dito sa daliri lang. No? So, ang pinag-uusapan dito is IEC standards when they have done a lot of experiments and tests in among populations, meron silang 5% population, 50, 95%. Ang ginawa nilang test dito, they subjected, of course, hindi yung tao, merong ibang part, iba tao, iba animals, ano? And they have seen na yung impedance natin nagbabago siya. So it's not fixed, no? So ano yung pwede nating kontrolin dito? Of course, if the human impedance hindi natin ito makokontrol, so we have to control the source. So kaya nga nag-decide dito based dun sa it's in Ohm's law, no? Yung 50 volts nasa safe voltage yan, o yung gagamit tayo mga natawag na extra low voltage, no, sa mga installation. Para i-ensure natin na walang makakadaan ng mga currents which is detrimental, to our body. Hindi tayo masyasyak. So napakahalaga na ma-decide natin during the design stage ano yung voltage na gagamitin natin. Dito pag alam natin kung ano yung mangyayari sa katawan natin, sa IEC meron kaming table na ginagamit yan. So we can, even the IEC have decided, nakita nila to, 50 volts sa AC and 125 volts sa DC, no, yung safety voltage. And the same with UL or the American side, 50 volts din. Kasi isa lang naman yung katawan natin, so pare-pareho yung voltage ang importante na makontrol natin dito. Okay? So ang requirement sa TT system, the short circuit protection device is usually not suitable. Kita naman natin, ano? So, mandatory talaga yung RCD, residual current device, ang kailangan natin dito sa TT system. Okay? Then we have the TN system. It's also a grounded system ito. And from here, dito na gumagamit ng PEE, protective earth conductor. No? Continue siya. So, meron kang fault, you must ensure na yung protective conductor mo is size, ano? As much as possible, this is what we call sa PEC natin, effective ground fault, ano? Path. Ito yung effective ground fault path na tinatawag, no? Na using the bonding conductor, okay, it will go to the source and it will trip, no? Your protective device. So makikita natin dito, the tripping of the circuit by the short circuit protection device, i-allow pa niya yan na magti-trip ka. No? Kasi mataas yung current niya rito, di ba? So even though the voltage is very high dito, again, it's above the 50 volts. So makakaroon ka pa rin ng kwan dito, ng effects sa human. What it will do with the equipment, it will protect the equipment, pero yung tao, we need to do some additional tinatawag na indirect protection, ano, sa IEC. So meron direct protection, meron pang indirect protection. So pinapakita lang dito na dito pag ganito yung system mo, magti-trip yung overcurrent protective device mo sa TN system, okay? Because of the high value of current. Then sa IT, ito yung first fault na sinasabi natin na continuity of service, very important, lalo-lalo na sa mga steel plants, sa medical facilities, healthcare facilities. Very common ito yung IT system, yung isolated, o yung tawag natin sa PEC, it's ungrounded, unearthed, ungrounded system. So, siyempre, mataas yung impedance mo, o wala kang impedance dyan, wala kang fault current na dadaan dito, mababa masyado. So, in this example, kung meron kang sa installation is the resistance is 10 ohms, yung sorry, yung RF mo is 0 kasi naka-bind dito, no? Banded. So Z equal mo is 3540. Okay? Equivalent kasi meron dito given siya. So ganito yung formula. Again, it's an Ohm's law. So 65 milliamperes. So mababa siya, no? It's below the threshold ng let go natin. UF niya, touch voltage is 0.65 volts. So there's no dangerous current. But mandatory yung signaling. So meron ka dapat monitoring. Okay, yung sa mga facilities natin sa mga healthcare facilities, meron monitoring ng fault and leakage current. Merong monitoring yan para malaman natin kung it will give also a way sa mga maintenance para meron silang time na hanapin kung nasaan yung fault. So meron silang alarm dyan. And sa smelting plant, sa production, very important, sa steel production, napakahalaga rin nito because the moment you cut the power during first fault, patay yung production mo, no? Laki nung contribution niya sa losses mo. Especially pag smelting plant ka, biglang naputol yung kuryente, tumigas lahat yung bakal mo doon sa process, then malaking losses sa production. So diyan malimit ginagamit yung continuity of service ang dito. Pero of course, may requirements na kapag nagkaroon ka ng second fault, then let the overcurrent protective device monitor this one. So i-trip natin yan yung yung protective device mo, no? Second fault na kasi ito eh. Doon sa una, makita mo alarm lang siya, no? Meron kang insulation, first insulation fault. So kailangan lang siyang i-monitor. Pangalawa, ground yung pangalawang phase mo. So, yun na, line-to-line fault na yun. So, we have the overcurrent protective device. Okay? Now, let's go now to the main, ito, mga kwan lang ito, mga kanina yung pinag-uusapan natin is about the earthing system. Now, let's go now to the earthing arrangement. Itong earthing arrangement, it's on the installation side na ito, hindi na dun sa source. So, ito yung mga background tungkol sa earthing arrangement o yung tinatawag natin protective earthing arrangement o yung banding tinatawag natin sa PEC. So it is popular and incorrect belief held by many people that earthing a metal object will assist in removing potential hazard caused by a fault. So earthing, ang sabihin nun, inert mo lang siya sa lupa. So yun yung misconception dito na mapoproteksyonan ka nun. Pag inert mo, di ba, yung exposed conductive part mo, okay ka na. So nakita naman natin dun sa example ng mga earthing system, di ba, yung TT. Di ba, wag ganun, delikado. So gagamit ka ng RCD. Dapat makakaroon ka ng continuous protective or bonding connection, para makakaroon ka ng protection. So earthing object does nothing to remove hazardous voltage or reduce touch or step voltage that causes several deaths each year. So nakalimutan nila, earthing, okay, ginawa mo, pero meron pang isa, makakasama pala dito eh. This is the bonding, So ito, improper earthing or bonding are a common cause of electrical accidents. So napakahalaga nito, especially on installation. Sa mga audit na ginawa ko, 80% of the problem na nakakaroon ng issue. I have seen na maraming problema rito sa connection, ano? Improper earthing or bonding. Probably next topic later, I can see actual applications na mga mistakes, ano, or violations on the improper earthing or bonding, ano, of electrical that had caused, no, electrical accidents, and also yung misoperation ng mga equipment. So, ang tawag natin dito dapat meron tayong tinatawag na effective, no? Kanina sinasabi ni Engineer Charles yung effective, ano, earthing or grounding. So, this effective earthing plays a key role in the proper operation of sensitive equipment. Mahalaga rin ito na sometimes we have an issue between yung grounding at yung ibang equipment ng yung mga electronic equipment, ano, na pinaghihiwalay nila na hindi pwede, kailangan hiwalay yung grounding nito. Napakaraming ganong mga nangyayaring mga issues, ano. But anyway, let's check this one. So dito sa ginawa ng research ng EPRI, yung Electric Power Research Institute, so 80% of all electronic system failures that are attributed to power anomalies are actually the result of electrical wiring or earthing errors. Ito, no, earthing errors or generated by other loads within the customer's facility. Mantakin mo, no? Imagine earthing errors. Kung titignan natin, simple lang, di ba? Pero saan kaya nagka-error? Kaya napakahalaga na during the design stage of the project, talagang i-emphasize natin, no? We have to put a diagram, no, of the earthing system, paano i-connect. Lalo na pag yung meron kang industrial plant, si residential siguro, di masyado yan, kasi simple lang naman. But it comes to a project like commercial, industrial plant. The design should include, ano, yung diagram or schematic na gagawin sa grounding, no, earthing connection. Kasi maraming ganyang project, kung titignan mo yung documentations nila, basta't sinabi nila you ground it according to IEC 2.50. Okay, if you are an expert, if you are the designer, siguro okay lang yan. Paano naman yung mag-i-implement, di ba? Okay, qualified siya mag-implement. Pero along the way kasi, kung sa initial stage ng design, na ilagay mo na lahat yung details, then implementation na lang. Then after the implementation, we have what we call the verification or validation of the installation. Dito pumapasok yung mga inspector, no? So, mga independent yan. Para sa ganon, ma-check nila ang bawat isa kung tama yung installation. Kasi kung hindi mo ginawa ito, when you energize the equipment, yung installation mo, makikita mo lalabas na yung mga problema. Then here comes the electrical audit na gagawin. Makikita mo, yun ang problema. So, very important ito, no, sa lahat ng electrical practitioners, especially take care of this one, no, yung proper, no, earthing arrangement o grounding or bonding ganyan ng mga natin, mga electrical equipment up to the source. No? So, nakikita natin, no, 80% ang dahilan. So, sabi ni Warren Lewis sa ECM, the famous ECM magazine, of all the power and earthing problems affecting electronic equipment, almost 90% are caused by electrical power. Ito na naman yung earthing conditions inside the facility in which the equipment is used. More importantly, almost 75% of the power quality problems inside the facility relate to earthing, which makes the single most important factor from a facility standpoint in having reliable equipment operations. No? So makikita natin yung kung saan nanggaling ito, na yung importance of an earthing arrangement sa facilities o sa installation. Now, sa standards, we have the specific sa IEC 60364. Meron nandun tayo sa part 5-54. Ito yung provisions, ano. So here, this is the standard. Okay, if you have this copy, pero wala pa tayong kwan dito, no? Hindi pa natin to na-adapt. But here is the standard. Okay? Then ano ba yung pwede natin itapat dito? Yung PEC natin, this is the Article 2.50. So ang tawag nila sa IEC is earthing arrangement and protective conductors. Sa PEC, it's grounding and bonding, ano? Yung title ng Article 2.50. So dapat alam natin yun, ano? Okay? Then let's go to the details. So earthing arrangement, protective conductors including protective bonding in order to satisfy the safety of the electrical installation. So ito yung scope ng standard. yung arrangement ng earthing mo, and the protective conductors. So, puro earthing to, protective conductors. Then, let's see some definitions para sa ganun, di tayo may mislead. Minsan, we talk about PEC, minsan IEC, depende kung sino yung kausap natin, baka malito tayo, mapagbali-baliktad natin, di ba? Kaya minsan, I have heard, I have read some ito kay the famous Mike Holt, and ito yung nagiging issue, yung understanding daw ng terminology kaya nakakaroon ng problema sa implementation. Because most of the, kahit na ikaw, electrical practitioner, if you don't understand the terminology, baka magpabaliktad mo, magkakonsya, kaka-problema. So ito yung nakita niya na issue. So you have to know the definition, yung terms, ng mga standards o yung code. Napakahalaga nito. So in IEC, conductive part of equipment, ito exposed conductive part, This is the conductive part of equipment which can be touched and which is not normally live but which can become live when basic insulation fails. So sa PEC naman nakalagay doon, normally kung babasahin natin sa 2.50, normally non-current carrying conductive materials. So what are these? Ito yung body, motor. Yung motor, body, yung motor mo, electric motors, panel boards, metal, may mga metal parts. Okay, ito yung mga conductive part of the equipment. So pag nagkaroon ng insulation fault, kunwari sa winding o sa mga internal insulated wires sa loob ng equipment, at yun ay nag-fail at pumunta doon sa body, ito na yung conductive part. So nagkakaroon ng problema, nagiging live siya. So yun ang exposed conductive part. Ito, medyo maiksi lang siya. Sa PEC, normally non-current carrying conductive, so masyado mahaba. Anyway, ito yung definitions niya. Meron din tayong tinatawag na extraneous conductive part. Okay, what are these? These are the conductive part not forming a part of the electrical installation. Hindi siya part ng electrical installation. But they are liable to introduce an electric potential. Generally, the electric potential of a local earth. So, dito sa PEC, ganito naman yan. Pareho lang yan. So, electrically conductive materials such as metal water piping system, metal sprinkle piping system, metal gas piping, and other metal pipings, as well as exposed yung mga structural steel members which like to become energized. So, pag nasa industrial plant ka, napakaraming doon, mga metals, di ba? Pag nasa parking area ka na made up of steel structure. So, all these things, ito yung tinatawag natin ng mga extraneous conductive part, So, which needs to be bonded or connected to earth, Okay. Then we have another here, earth electrode. Kanina nabanggit ni Sir Charles ito. It's a grounding electrode, PEC. So it's a conductive part again, which may be embedded in the soil or in a specific conductive medium, concrete, in electrical contact with earth. So meron siyang contact sa earth mismo, sa lupa. Okay. So PEC is a device that establishes an electrical connection to the earth. So makikita mo rito, ginamit ng PEC, yung salitang earth, So nagagamit din nila yan. It's the earth itself, yung soil, lupa. Okay? And we have another one here in concrete embedded foundation earth electrode. Okay? Meron dito concrete encased electrode, sa PEC. Okay? So these are the terminologies. So meron pang iba rito. We have called earthing conductor, And in PEC, we have the grounding conductor. A conductor which provides a conductive path or path of conductive to conduct between a given point in a system, okay, or in an installation or in equipment and an earth electrode network. Okay, grounding conductor, a conductor used to connect equipment to a grounding electrode or electrodes. So ito na yon, yung sa source mo, limbawa, meron kang neutral, connect mo sa earth o sa ground. So meron kang conductor between the electrode saka yung sa system neutral mo. So these are called the grounding conductor. So of course, earthing arrangement is about the standards and all electrical connections and devices involved in the earthing of system, installation, or an equipment. So grounding arrangement, all the electrical connection devices. So pareho lang yung kanyan, yung ibig sabihin niya, earthing arrangement, grounding arrangement. Ito may importante, yung main earthing terminal is the terminal or bus bar, which is part of the earthing arrangement of installation and enabling the electrical connection of a number of conductors for earthing process. So ito yung main, dito lahat pupunta, no? Yung protective conductors natin, no? Yung grounding conductors, diyan din lahat pupunta siya. So main bonding jumper, so the connection between the grounded circuit conductor and the equipment grounding conductors at the service. O parang lumalabas sa service ito eh. Pero dito naman sa IEC kasi, doon siya sa just before the installation, ano, nandun yung main earthing terminal block. Anyway, meron tayong diagram dyan mamaya sa based on IEC. Then ito yung importante, no, that we know the equivalent ano yung bonding conductor or jumper, ano naman yung protective conductor. Okay? So here in the conductor sa IEC is a conductor provided for the purpose of safety. For example, protection against electric shock. Okay? And we call it sometimes protective bonding conductor, protective earthing conductor, or earthing conductor. No? So protection lahat, protection purposes. So sa PEC, it's a reliable conductor. They call it the bonding conductor or jumper. It's a reliable conductor to ensure the required electrical conductivity between metal parts required to be electrically connected. And very important term is what we call the protective bonding conductor. Ito na yun, ha? Protective conductor provided for protective equipotential bonding. Pare-pareho, no? Sa installation, dapat pare-pareho yung potential mo to ground. So pag nagkakaiba-iba yung potential mo to ground, magkakaroon ka ng potential gradient doon. So yun ang yung magiging issue, no? When it comes to protection of person. And we call that in PEC, ito yung very famous, is the equipment grounding conductor or called EGC. You know? So the conductive paths that provide a ground fault current path and connects normally non-current carrying metal parts of equipment together and to the system grounding, you know? Okay? Grounded conductor or to the grounding electrode conductor or both. It is recognized that the equipment grounding conductor also performs bonding. Okay? So, it also performs bonding kasi i-connect mo yung lahat ng body, yung conductive, yung tinatawag natin exposed conductive part. No? And where it is going, pabalik doon sa source. Ano? Yun ang pupuntahan niya. Kasi kung meron kang fault, lahat ng fault, ground fault, earth fault, or whatever it is, it goes back to the source. Para sa ganon, yung protective device mo can monitor and sense this one para mag-trip siya. Okay? So, napakahalaga nitong equipment grounding conductor or protective IEC protective bonding conductor. So, there is an additional here called the functional earthing conductor. Ito yung, meron kasing dalawang earthing sa installation, protective purposes, at saka yung functional earthing. You know? So, yung functional earthing a point or points in a system or in installation or equipment for purpose other than electrical safety. Ano yung other than electrical safety? Yung function ng mga electronic devices, may mga data with data requirements, ano? So meron kang mga shielded cables na ginagamit communications sa industrial. Makikita mo doon na we have to have a separate tinatawag na functional earthing, no? Yung mga shielded yung shield ng signal cables mo ay di mo pwedeng i-mix dun sa ground, i-connect mo siya sa separate na functional earthing conductor. Pero lahat ito, either protective earthing or functional earthing, pupunta lahat ito sa main earthing, ano? Siyempre, may pupuntahan lahat yan, pero hindi mo lang siya i-mix dun sa installation, no? So, meron tinatawag na functional earthing conductor, especially sa PEC, they use this one in signal reference structure. So magiging signal reference, no, ng mga equipment mo. Okay? Then I will show you now the earthing arrangement para lalo nating ma-appreciate yung terminologies na mga ginamit dito. So what are these? Ano? So this is an example from the IEC. Makikita natin dito, you have all this one. So ang nakalagay dito, it's not a single line, pero ito talaga yung single line diagram na ito. It's all ground conductors, ano? Protective conductors. Okay, let's see what's this. Okay, ito yung symbol niya. So if you see down this one, merong MET, M-A-T. Yung MET, ito yung main earthing terminal. Okay? Main earthing terminal, if you see all this one, ito yung pinaka-center point ng earthing terminal mo sa installation. Okay? So we have a T1. Yung T1 na ito is a concrete or soil embedded foundation earth electrode. So ito yung T1, yung nasa baba. Ito yung nasa ilalim ng lupa, no? O foundation na nakasama dun sa bago binuhusan ng concrete. So nakagawa ka ng tinatawag nating concrete embedded earth electrode system, ano, sa T1. So dito meron tayong SEBT, supplementary potential bonding terminal. Ito yung nasa taas, nasa loob na, kunwari ito bathroom. So meron tayong kasi napakalayo naman kung bathroom mo, lalagay mo pa dito, di ba? So masyadong malayo kung high-rise building ka. So hindi practical. So ganito lang yung kanyan, yung connection, no? And here we have the yung mga conductors, ano? Yung from 1 to 5, makikita natin dito, ang tawag dito yung number 1 is protective earthing conductor called PE. So nasaan yung number 1? So it's between the MDB, yung MDB mo, meron kang doon PE or pen bus bar, yung kaninang diagram na pinakita natin. Doon mo i-connect, no? Yung yung sa MET, yung PE niya. Okay? O kung meron kang 1A, ito na. So we are showing here yung installation, wala yung yung sa source, ano? Power system. So kung meron kang power system, yung 1A. So protective conductor, PE or pen, if any, from supplying network. So dito na nakakonect, no? Ko-connect mo muna dito sa MDB mo, yung sa source. O malimit, ito naman yung ginagawa natin sa mga MDB, nandiyan talaga eh. Then magpo-provide ka ngayon ng PE conductor, then you create yung MET mo. Malimit, nakikita ko sa mga substations dito, they put this one in the wall, no? Yung mga bus bar doon na may mga bolt and nuts doon naka-connect lahat ang protective conductors, no? Okay, then we have the number 2, ito na yan. Ano yung number 2? This is the protective bonding conductor for connection to the main earthing terminal. Ito na yung EGC na tinatawag, no? So 2. Ito. Okay, saan pa yung 2? So doon siya. Then we have the number 3, protective bonding conductor for supplementary bonding. So ito, doon sa bathroom na ginawa niya. Okay. Then item 4 is the down conductor of lighting protection system, if any. Kung meron kang LPS dyan, ganito yung pagka-connect. Anyway, it's another subject yung LPS, ano? Kasi very specific yung grounding na system niya o earthing system ng LPS, ano? And also you need an expertise on how to install the LPS in a system, ano? In a building. So makikita natin nakakonect pa rin siya sa grounding, no? Sa T1, sa foundation earth electrode, or may sariling T2 earth electrode for LPS if necessary. So hindi pwedeng sarili lang niya, no? Yung LPS, baka yung magiging issue natin dyan ay may sarili. Hindi, i-connect pa rin yan doon sa one. Kasi kung mas marami ang T1 mo, electrode mo, mas makuha yung protection mo. Kasi yung LPS naman is about voltage disturbance naman ito, no? Yung protection ng equipment against voltage disturbance. So by earthing the LPS, medyo ma-reduce yung natin, yung voltage disturbance due to atmospheric na tawag na conditions, no? Okay, we have the earthing conductor, yung 5. Okay, between the protective, yung electrode, ito yung kanina yung definition niya. Okay. 5 ito, punta sa MET. Then we have the exposed, ito na yung conductive part. Anong gagawin mo sa mga M? Lahat ng exposed conductive part. Okay, protective earthing, ano? Kailangan mo yun. I-earth mo dun. Kunwari, nandun ka sa distribution na, from the MDB, meron ka pang 1 dyan, protective earthing conductor. Okay, itong or bonding, kakaroon ng connection lahat ng exposed, okay, conductive parts dun sa PE bar. So sa DB mo meron kang tinatawag na PE bar, no? Okay. Then yung M mo, then PE terminals and distribution board. Then punta naman tayo sa mga extraneous conductive parts, not part of the electrical installation, pero pwede siyang magkaroon siya ng effect during induce ng voltage dito sa mga steel structures natin. So ano yung mga yan? Ito yung water pipe, no? Mga water pipes, yung C1 dito sa tatlo na ito. So kung metal parts yun, i-connect mo rin siya, no? Protective banding, i-connect dun sa main earthing terminal. So ano pa yun? Wastewater pipe, kung hindi naman sa PVC, naka-expose, yung pipes mo, steel pipe. So i-earth mo rin siya dito sa MET, i-connect mo rin siya. Then gas pipe, ito medyo delikado dito, gas pipe, So actually merong mga regulations naman sa mga supply ng mga supply lines ng mga gas na you have still to follow yung requirements ng supplier mga gas. So but here if you see sa IEC meron silang tinatawag na insulating insert, no? So insulated. So ang ibaband mo rito yung sa installation mo. Naka-expose yun, so ibaband mo siya sa earth. Pero dun sa supply side, galing na sa supply side sa supplier nung gas. So meron kang insulating, hindi siya connected, Ayaw mo namang i-connect lahat ng pipe pati sa labas ng installation mo or sa premises mo. So you need to put what we call a insulating insert. Very simple ito para walang connection yung sa internal pipe mo saka yung sa external na galing sa utility, sa gas utility. Okay, air conditioning. So meron mga air conditioning, C4. Where is C4? C4 is here. So meron kang conductive parts doon, exposed conductive parts. So kailangan mo na naman i-connect siya sa main earthing terminal. Okay? And of course, C5 is heating system. Lahat ng exposed conductive part niya, i-connect mo rin siya. Then C6, water pipe, metal. Ito yung nasa bathroom. Sa ngayon naman sa atin, mostly PVC naman ito sa mga residential. Pero pagpunta mo sa industrial, maring gagamit sila ng mga metal or wastewater pipe, mga metal pa rin. So you have still to connect that, to band that dito sa natin, sa mga protective earth terminals. Okay, so ito yung illustrations ng earthing arrangement based on IEC 5-52. So earthing or banding, ito yung dalawang salita na dapat natin hindi ma-mix yung dalawa, papagbaliktad. So earthing is to provide an intentional connection to earth, which is reliable and suitable for protective requirements of the installation or for functional requirements, and it's suitable for the foreseeable external influences, mechanical stress and corrosion. So napakahalaga na yung mga grounding rods natin na gagamitin, mapo-foresee natin na maybe merong corrosion later mangyayari, or paano natin i-connect, yung interconnect yung earthing natin. Kasi the moment na maputol ito, due to corrosions, due to loose connections, napakahalaga na magkakaroon ng tinatawag na continuity, ng earthing. Okay, so it's still a protective, for safety, protection for safety sa mga equipment natin. Yun ang mahalaga rito, Then banding, ang pagkaiba ng banding is the interconnection of conductive parts or yung exposed conductive parts for the purpose of maintaining a common electrical potential and to provide an electrical conductive path that will assure electrical continuity to conduct safely any current likely to be imposed. So babalik siya dun sa source, and pag meron kang banding, your OCPD will react accordingly kung dun sa settings niya, kung ano yung na-sense niyang fault, ground fault. Okay? The earthing arrangement may be used jointly or separately for protective and functional purposes according to the requirements of the electrical installation. The requirements for protective purposes shall always take precedence. So ito yung napakahalaga, whenever you discuss something with ito ginagamit minsan ng mga suppliers, yung mga manufacturers ng equipment. Hindi pwede nyo ipagsama-samahin yung mga magkaroon kami ng hiwalay. Merong mga ganyang mga discussions, separate daw yung grounding niya because it does not want to affect the equipment, yung electronic or whatever equipment is that ayaw nila. So just take note, even sa PEC and in IEC standards, ang point dito, yung protective purposes is more important, Kasi ang buhay, kapag yan nakuryente yung tao, mas mahalaga yun kaysa sa equipment. Di ba? We have to check that mindset na gano'n, ano? Pero anyway, hindi naman natin iiwanan na makakaroon ng problema yung equipment. Of course, there are criteria, there are rules, ano, on how to do the earthing para sa mga data center, sa mga equipment natin, mga electronic equipment. So, na-establish na yan eh. Pero wag lang siya sabihin sana ng ibang mga electrical practitioners na hindi, paghihiwalayin kasi hindi pa pwede yun. You are violating the requirements of the code, pati na rin dito sa earthing requirements ng IEC, that is a violation. So, dito, sinasaad na protective measure takes precedence, is most important. Ano? So, yan ang magiging mindset natin. Ano? Whenever we have some discussion like this, then okay, i-address natin ano yung issue mo, di ba? Equipment, bakit na kailangan iwalay mo. Pero alam nyo, ginagamit din ito sa mga warranty ng mga equipment. Kapag hindi mo iniwalay mo yan, wala nang warranty yung equipment sa supplier kasi sabi nga ng manual nakalagay iwalay yung earthing di ba? Maglagay ka ng sarili mo na ground rod o earthing dun sa equipment mo. So ang problema yun nga nadi-defeat yung purpose, yung protective function ng grounding o yung earthing. Okay? So that's very important to consider. Where provided earth electrodes within an installation shall be connected to the main earthing terminal using earthing conductor. So yung sample natin kanina, nakalagay yung grounding electrode sa system, sa earth, dun sa baba, sa lupa, then kukonect lahat yun sa pan natin, sa main earthing terminal. So installation does not have its own electrode kasi nga kung nasa main terminal talaga doon sa source, meron siyang doon, MET nandun. So kahit hindi mo na kailangan pang maglagay ng sarili mong earth electrode, lalo na sa high-rise building. Hindi ka na pwede wala naman lupa doon di ba? So magpapatakbo ka ng tinatawag na bonding, yung EGC conductor papunta doon sa main earthing terminal. So ito, mahalaga pa to, where the supply of an installation is at high voltage, requirements concerning the earthing arrangements of the high voltage supply and of the low voltage installation shall also comply. Ito yung another part of the standard is the part 4.44. Ito yung kanyang sinasabi ko. One of the important things na ma-address natin is yung temporary over voltages due to earth faults, in the high voltage system and due to faults. So sa utility, nagkaroon ng ground fault dun sa system, Ano ba yung effect dun sa low voltage, di ba? So malimit may mga nangyayaring problema. So what is this condition, of course you can mitigate temporary over voltages. Nandiyan naman paggamit ng SPD o TVSS, yung surge protective device, isa yan, But in earthing systems, we have to know yung ano yung level of the fault, So ito yung sa IEC, ito yung calculations nila. I will show you the diagram. So meron kang low voltage installation, you have here a substation, malapit lang siya, Nasa isang facilities o area lang ito, sa isang premise. So you have here a delta Y transformer. So whenever there is a fault sa HV side, nagkakaroon siya ng effect doon sa low voltage, Baka mamaya, di natin malaman to bakit na ganun, dapat alam natin ito as an electrical practitioners. Saan kaya nanggaling yung fault? Bakit kaya nasunog itong equipment ko? Bakit na ganun? Tama naman yung earthing ko. Nangyari dito, maaari nagkaroon ka ng fault sa high voltage. So still the standard is considering yung mga mangyayari sa around the external of the installation. So ito, pag nagkaroon fault, makakaroon ng effect na U1 dito sa transformer mo, sa power system mo. Then sa low installation mo, makakaroon ng U2. Tignan mo na lang kung may nakakonect ng mga load dyan dito sa line 1 mo. So makakaroon ka ng tinatawag na effect, yung voltage na U2. Okay? So are we allowed to connect the earthing? So sabi rito sa standards, interconnection of high voltage RE and low voltage RB. So interconnected, yung dalawa, yung earthing, yung conductive, exposed conductive part ng substation, i-connect mo siya dito, yung dalawa. Okay, naka-connect yan. So meron isa, separation of high voltage RE. So ang general method used is interconnection. Because the high and low voltage earthing systems shall be interconnected if the low voltage system is totally confined with the area covered by the high voltage earthing system. So confined siya sa isang facility, so dapat i-connect mo siya, no? And these are the effects of the voltage. Kung titignan natin itong mga effects sa TT, sa TN, no, with RE and RB interconnected, no? Yung dito yung RE RB, take note of this, itong dalawa na to, no, the neutral of the transformer saka yung exposed conductive part, no? So ito yung magiging effect sa calculation sa IEC standards. So U1 makikita mo na dito, ano? Yung UO mo, ito yung highest phase to voltage mo to ground. So kung halimbawa meron kang 400 volts, so 230. So okay lang yan pag may 230 volts ka, pero magdadagdag siya rito. Merong RE times IE. So you are going beyond, ano? Yung kakaroon ka ng temporary over voltages, no? Okay? So especially itong mga itong mga may plus na ganyan, no? O yung square root of 3 tumaas. Makikita natin yung effects, ano, ng mga fault sa medium voltage. So ito yung mga formulas niya. Talagang nag-i-increase, ano, sa kanya yung voltage, mga temporary over voltages. Okay? So if you know this, alam mo na kung ano yung i-design mo, no, sa facilities mo, sa equipment mo. You can do the design. Ano ba yung kailangan ko? Kailangan ko ba ng surge protective device? Kailangan ko ba ng mga ibang devices pa to mitigate, ano, the problem of temporary over voltages, ano? Ang pinaka-common yung gumagamit ng SPD, and SPD is another topic. Malaking topic diyan na i-discuss, ano, on how to install the SPD, saan mo ilalagay, at nakalagay nga doon yung pati yung earthing niya ng SPD is very short, ano, walang loop. So directly to the talaga, to the earth ang connection niya, okay? So earthing arrangements are intended to provide a connection to earth which is reliable and suitable for the protective requirements of the installation, and can carry the earth fault currents and protective conductor currents to earth without danger from thermal, thermomechanical, and electromechanical stresses from electric shock arising from these currents. It's also relevant, no, and suitable for functional requirements. Okay? So, dapat dito sa design natin, mapo-foresee natin yung mga external influences. We can easily select the materials na gagamitin natin na it's not affected by mechanical stresses or any corrosion. Kasi kung papabayaan yan, yung rod mo nakabaon na yan sa lupa, hindi mo na nakita, or you don't do maintenance testing or annual or yung periodic, magugulat ka na lang, baka yung rod mo corroded na, wala nang contact sa earth, di ba? Okay, so it's very important to look on the earthing system, no, yung functionality niya, yung integrity is also very important sa safety, no, protection for safety. So consideration shall be given to earthing arrangements where currents with high frequencies are expected to flow. Ito yung tinatawag namin sa 44-4, measures against electromagnetic influences. So sa standards, magkasama kasi itong dalawa, yung voltage disturbance, temporary over voltages, saka yung measure against electromagnetic influences. And also it complies with the protection against electric shock. Okay, so let's see some electrodes yung ginagamit as part of this standard. Ano yung materials? Dimension of earth electrodes, no? So first thing is withstand corrosion and to have adequate mechanical strength for the intended lifetime. Yung sinasabi natin na dapat yung pagpili ng mga devices pa lang ay nasa standards na, no? Okay, so dito sa right may table. Ito yung parts, yung different materials being used sa IEC. Of course, very common ito, yung steel embedded in concrete, bare or hot galvanized or stainless steel. Ano? It comes in round wire or solid ganito. Then these are the diameters and cross section. No? These are minimum. Ano? So pwede mong lakihan kung gusto mo. So stiff hot dip galvanized, steel copper sheeted. Okay. Round or installed vertically. Steel with electro-deposited copper coating o stainless steel. Pero medyo expensive itong stainless steel. And of course, we have the copper, no? Very common na ginagamit sa ating mga use as a grounding electrode. No? Okay. So the following are examples of earth electrodes which may be used. Concrete embedded foundation earth electrode, soil embedded foundation earth electrode. We have the metallic electrode embedded directly in soil vertically or horizontally, that is the rods, wires, tapes, pipes, or plates. No? And of course, the metal sheet and other metal coverings of cables according to local conditions or requirements. Other suitable underground metal works, pipes, according to local condition requirements. So still, dapat yan, merong kondisyon, no? Yung paggamit ng mga pipes. In other countries, ibang national committees sa Europe, they don't allow to use the pipe as a grounding. No? So may kanya-kanyang kwan kasi yan regulatory requirements at ibang bansa. No? So welded metal reinforcement of concrete, except pre-stressed concrete embedded in earth. So let us see some example of earth electrodes, earth rods. So ito yung copper band na steel siya, pero coated. Of course, this one, merong product standards when it comes to earth rods. Okay, you have to the manufacturer has to follow standards, no, in manufacturing is earth electrode. Hindi basta-basta maglalagay lang ng earth electrode, no? So we have to see also yung quality ng product, specifically complying to certain product standards and earth rods. No? Ito yung solid copper earth rods, mga example ito na ginagamit. Then yung sa building, yung foundation earth electrodes, we have this one. Okay, steel wire, ang tawag nila rito. Then we have stainless steel wire. We have steel strips, no? Dito, mga ito, steel strips and the wires. And here's the application. Ganito, you have reinforcing bars, no? Then you have this steel wire, no? Ginagamit dun. So naka-clamp siya dun sa foundation, sa rebars, no? Then of course this one, merong mga steel strip na ginagamit. Ito, naka-band lahat ito. So meron siyang connection, special connections ito. Bago siya buhusan, so merong ginagamit na mga electrodes, earth electrodes. Ganyan. Okay? So makikita natin dito yung installations of the earth electrodes. So maganda rito, dapat inspeksyonin ito kung meron kang installations na gagawin na ganito. There should be some sort of validation sa lahat ng gagawin. Bago buhusan yan, merong validation or inspection. Kaya sa IEC, meron tinatawag na verification during installation. It's very important to validate all this installation para makita natin na proper siya. No? Otherwise, kung binuhusan yan, wala ka na makita, hindi mo na alam kung ano nangyari doon sa ginawa ng mga installer. No? So it's very important to verify this one bago nila ilagyan ng backfill or concrete backfill. So this is an example of an electrode embedded in a conventional concrete. So yung mga interconnections niyan, makikita natin yan. There are special mga materials, there are manufacturers who are involved in supplying this type of earth electrodes. Very specific sila, and they comply with certain standards para ma-comply nila, pati yung installation standards. So meron silang mga ginagawang mga connections, mga ganyan. May mga connection lug to UPS, connection to reinforcement, foundation earth electrode, then meron pang well bushings, against protected against, kasi nilalagay yan sa labas pag nabuhusan na yan. Yung mga green na yon, ito yung kanya, yung earthing niya, no, access, mga yan. Para when it comes to measurement later, you want to connect, maglagay ka ng earthing bar dyan, okay, pwede mo i-connect dun. Okay. Minsan may mga building ako in-audit, hindi ko malaman kung nasaan ang pit, nasaan ang mayroong mga ganyan. So be very careful sa mga, especially sa mga designers natin, na wag lang natin banggitin according to Article 2.50 of the PEC, shall be ganon. Dapat maglagay tayo ng details para sa ganon maging mas maayos ang natin, ang grounding or earthing systems natin. And specifically, merong as-built. So when it comes to preventive maintenance, when it comes to inspection, alam natin kung saan tayo pupunta. Alam natin kung saan natin hahanapin kung magkakaroon ng problema. So it's very important to have a proper installation on the earthing, especially yung mga na-embed na, yung mga bubuhusan. Okay? And this another one, providing a ring earth electrode. So for functional, merong ito kasi may functional siya earthing Okay, bonding conductor. Okay. So ganito yung ginagawa sa mga installation. So the cross-sectional area of earthing conductors sa IEC should not be less than 6 mm squared for copper and 50 mm squared for steel. So ito yung sa IEC standards. So when a bare earthing conductor is buried on the soil, so yung dimensions and characteristics shall be in accordance with table 54.1. So merong guide dito, So aluminum conductors shall not be used as earthing conductors. For what reason? Alam natin aluminum, pag nasa lupa yan, naibaon siya or whatever, kakainin siya ng corrosion. So magkakaroon tayo ng problema. Mas mabilis na makorrode ang aluminum. So the connection of earthing conductor to earth electrode shall be by exothermic. So very important. Exothermic welding, pressure connectors, clamps, or other suitable mechanical connectors. So you have to use the correct connection, way how to connect it. Yung iba nakita ko, ginakon ng GI wire, hindi pa pwede yun. Kasi maglulus yun, kakainin yung GI wire mo. Wala ka ng loose connections ka na sa earthing mo. So exothermic is the ginagamit sa very common kasi welded siya. Okay. So in every installation where protective equitable bonding is used, ito yung main earthing terminal na yung MET, yung kanina yung pinapakita natin. Then because this will provide protective bonding conductors where you connect it, earthing conductors, protective conductors, functional earthing conductors if relevant kung meron ka. Dito lahat i-connect, isang point lang sa installation. Then each conductor connected to the main earthing terminal shall be able to be disconnected individually. So this connection shall be reliable and such that it can only be disconnected by means of a tool. So kailangan bolted. Ganito, yung kung nakikita natin sa mga installation, meron ka makikita sa wall, sa substation. Ganito, So you will connect all your earthing conductor dito with a lugs, yung crimp, naka-crimp yung lugs niya. So i-connect mo siya dyan. So it cannot just be disconnected. Tulad ng sinasabi ng standard, you must use a tool. So socket wrench, open wrench para matanggal mo siya. So sa preventive maintenance, siyempre magkakaroon pa din ng testing dyan. And of course, retightening sa preventive maintenance ng mga connections. Okay? Then there's another one here where you want to disconnect, okay? For testing purposes. Kasi kunwari ito yung disconnect, ito? Naka-connect sa main earthpan mo, sa grounding rod mo. And if you want to test, so pwede mo siyang i-isolate. Otherwise, tanggalin mo lahat siya naka-connect dun sa mga board, mas malaking trabaho. So pwede mo siyang i-test by just isolating. Kaya meron siyang link, isolating link na ginagamit. So okay, an example of connection. So kung ang ginagamit ay mga protective conductors aside from the requirements, so this is the way how to calculate sa IEC standards, the minimum cross section according to this one, this table, okay? So meron siyang mga formula na ginagamit, and these are the formula na ginagamit sa protective, where S is the cross-sectional area in square millimeter, I is the RMS value expressed in amperes, of the prospective fault current. So meron siyang calculation. And time is the operating time in seconds of the protective device for automatic disconnection. Okay, then K is the factor dependent on the material of the protective conductor, the insulation, and other parts of the initial final temperatures. So importante na malaman mo itong K. And in identifying K, meron siyang formula again. Ito kasi makuha sa IEC, maraming formula yan because they have done this, and we know that IEC is a performance-based standard, no? So they have done a lot of testing, calculations. So ito yung magiging K mo, no? So using this material, kung depende sa materials mo na gagamitin sa standards, sa protective conductors mo. So in summary, let's summarize this. Correct selection and implementation of the earthing arrangement are key to ensure. So mahalaga, protection against electric shock. Number 1, so ito yung personal protection. And number 2 is the protection against transient overvoltages. Okay. And to reduce the electromagnetic effects, no? Yung tinatawag na electromagnetic compatibility ng system mo, no? Ng mga devices mo. Okay. Then this one, the IEC 6036454, yung pa natin, addresses the earthing arrangement. Then we have here for designing electrical installation, kailangan mo itong 6036-4 para ma-design mo properly yung earthing arrangement, no? And of course, you have to consider yung 62305-3 applies when a lightning protection system is installed. So kailangan mo yan kung sa IEC, ito yung mga ginagamit na mga standards. Because we know in the PEC, yung pag inert mo or ground mo yung neutral o yung grounded part, no, yung power, yung transformer mo, yung source mo, ang nakasaad doon is to reduce, no, yung effects ng voltage, no, induced voltage due to lightning. So ganito yan, i-consider dito sa 60364, particularly sa dust 3, no, yung effects ng lightning. Then dito sa kwan, there is no unique solution but different. So iba-iba, no? But should be considered to find the most appropriate one. So depende sa applications mo. Yeah, you can do design, but we have to use, the minimum requirements is to use our code sa Article 2.50. So nandiyan na lahat yung provisions on earthing and bonding. And if you go to specific locations, no, meron naman tayo sa PEC mga specific locations for healthcare facilities, grounding na ginagamit doon. Meron tayo sa PV, sa mga switchboards, no. So lahat ng equipment meron yan. Katulad ng IEC sa Part 7 ng 60364, it gives a specific. So kung sa 2.50 hindi mo makikita doon kasi nandun yung general requirements, provision. Punta ka doon sa ibang section ng PEC. And if you are using IEC, punta ka naman sa specific, standards. Ang nagiging issue lang sa IEC ngayon is that it's very difficult to have access on the standards. Hindi mo yan makukuha sa internet. Kung gusto mong kunin, magbayad ka. Minimum, probably, is around $250, para makuha mo yung standards. So, ang advantage nito, we are in the BPS and we have access to the standards. Pero siyempre, nire-request namin and it's a copyright, so hindi pwedeng kopyahin. But of course, you can use yung mga parts doon sa mga presentation. You are allowed to use this one. Para sa ganon, our main purpose here is that to introduce yung IEC standards sa ating mga electrical practitioners. Ang predicament kasi natin dito, we are using the PEC and then most of the devices na ginagamit natin ngayon sa lahat ng installation, majority is IEC based. So, maaari magkakaroon tayo ng issue on how to what we call this, to coordinate the two, yung harmonized standards. So, ang ginagawa namin sa BPS, technical committees, is to try to review these standards para sa ganon magawa siya as Philippine National Standard. When it becomes a Philippine National Standards, it's easy for all our electrical practitioners to access the IEC standard kasi naging PNS na siya eh. Then we can use this one as a guide. Ano? Very important, I want to emphasize, the IEC standard is a guide only. So, hindi naman siya mandatory or whatever kasi ang mandatory requirements natin as minimum is the PEC. So, we can use the IEC standard as a guide. So, if we go beyond the minimum, so okay lang siya sa installations natin. And also, it will help our electrical practitioners, especially when you go abroad, when you go in other Asian countries, and you will see that most of the installations are based on IEC installation. So pag nandun ka, magiging competitive ka, sa ibang mga electrical practitioners sa ibang bansa, because you will be aware of yung IEC standard. So anyway, I want to thank everyone for listening. As what was mentioned a while ago by our very own Engineer Vic Santos, na even with this age, our age, we continue to learn. It is a continuous learning process sa bawat isa. And the thing here, if you want to continue to learn, you must enjoy. Enjoy mo yung ginagawa mo. Para sa ganon, you will be encouraged to do it and to share whatever knowledge we have. Because knowledge, I believe, is for everyone. Kaya maraming salamat sa lahat, and thank you for attending this presentation. Thank you very much. Thank you very much.
That ends the presentation of Engineer Conrado Benondo. Thank you very much, sir, for that very informative lecture. Now, for the awarding of the Certificate of Appreciation, may we call on once again one of the members of the TCPDC, Engineer Max Adarlo.
Institute of Integrated Electrical Engineers of the Philippines Incorporated, Accredited Professional Organization, Certificate Number I-APO-016, PRC Accredited CPD Provider Number 0EE-2020-007. This Certificate of Appreciation is presented to Engineer Conrado C. Binondo for imparting his knowledge and expertise as resource speaker on the topic IEC earthing arrangement and protective conductors via Zoom, given this 12th day of June 2021. Signed by Engineer Joseph Darren Claire S. Subicar, Chairman, IIEE Training and Continuing Professional Development Committee. Signed by Engineer Alan Anthony P. Alvarez, 2021 IIEE National President. Thanks a lot, sir, for a well-discussed topic. Any few words for the acceptance? Any few words, sir?
Yes, nasabi ko na kanina. Close ko, nauna. Okay. So that's all. Thank you very much for inviting me. Thank you.
Okay, sir. Have a picture of you accepting the certificate of appreciation po. So, 1, 2, 3, smile. Okay, there you have it. Now, let me call on Engineer Charles Singson to join us in the Q&A. Unfortunately, Engineer Jess Santos is currently having his presentation at the Metro Central activity, but he already answered some of the questions earlier, and he would also like to say that you may send him an email if you have any question to him. So, hello, Sir Charles. Ayan po, dito na po yung dalawa nating speaker. So I will just read the questions from the Q&A box, sir. One is, okay. This is from Sir Jerven Magpuno. How to compute the neutral conductor for 3-phase 230 volts Y system kung wala naman pong line to neutral loads?
Okay.
Ayan po.
Anong name uli yung yung nagtanong?
From Sir Jerven Tagpuno.
Yeah, Jervin. Jervin, I presume na 3-phase ka, pero nakakonect yung neutral mo. Nakakonect, neutral mo pero wala kang line to neutral. Okay? Nagkakaroon lang kasi ng caret yung neutral pag may unbalance ka dun sa line 1, line 2, line 3 mo. So, yung pag-compute ng unbalanced caret with the neutral, yung binigay ko, yung pinakita ko kanina, yung I neutral, yung square root of line 2 plus yung line 1 square plus line 2 square plus line 3 square, ima-minus mo yung line 1 times line 2, ma-minus mo yung line. Anyway, bibigyan naman kayo ng presentation. Bibigay ko kay Yasmin para may reference kayo for the formula. Okay.
Anyway, in addition, kung you are using a three-phase, wala kang neutral load, so that will come as you need only the protective, earthing, yung PEN na tinatawag, PEN or PE. Because as an installation, as I have discussed, my equipment you need to connect, through a bonding o yung protective earthing bonding, yung exposed conductive part mo papunta dun sa source, so actually merong yung kanina yung binigay ko na sizes nandun sa formula, nandun sa presentation. You can calculate yung hindi na neutral ang tawag doon because you don't have any connection. So the purpose really is to have a protective
Yasmin? Yasmin? Yasmin?
Hello, sir.
Yeah, Yasmin.
Okay, there seems to be a trouble with my connection from the other device, sir.
Yeah, even si Engineer Conrad, nawawala siya. So we suggest ko na lang siguro, i-close namin yung video, even si Engineer Conrad, para hindi mag-agawan yung bandwidth.
Okay, sir.
Okay.
So, hope that answers the question of Sir Jervin Magpuno. Sir, if you have a follow-up question, kindly raise your hand. We will now proceed to the next question. It's from Sir Nathaniel Guevara. So most of the electric cooperative, particularly in the rural areas, applies protective multiple earthing line to ground. Whilst in most urban areas such as NCR, it applies line-to-line system. What are the reasons?
Yes, si Engineer, anong name ulit? Engineer?
Nathaniel Guevara.
Nathaniel, okay. So it's a good question. Yun yung kinikwento namin kanina, yung earlier na, di ba may mga dumating na mga different voltages na appliances dito sa Pilipinas. Kaya ginamit yung line to neutral. Kung nagkaroon ka ng line to neutral, yung sa single phase transformer, nagkaroon ng line to neutral, yun yung 110 mo. Tapos yung line to line mo, yun yung line 1, line 2, 230 volts. Okay, karamihan sa probinsya, which is under yung mga cooperatives, line to ground yung system. Live yung line 1, tapos yung isang line nila, yun yung naka-ground. Tapos naka-float yung neutral. Pero dito sa NCR, yung Meralco franchise nga, line to line na yung ginagamit. So, yung transformer na may neutral pa rin, pero mukhang kung wala kang naman, wala kang 110 volts, 115, hindi mo na magagamit yung line to neutral. Kaya line to line, 230 volts. Both line may voltage in reference to ground. Kaya sabi ko kanina, mukhang mas safe yung yung nasa probinsya dahil kasi yung switch mo, wala namang tugang na switch, di ba? So isang gang lang lagi. So pag pinatay mo yung switch, ng ilaw mo, may voltahe pa rin yung isang line. So mukhang mas safe na yung line to ground. Okay, yung kwan naman, yung multi-ground na sinasabi mo sa mga cooperative, na kasi malalayo siguro yung mga poste nila, kaya nag-ground sila with a certain distance para makapag-establish lang ng magandang reference mo to ground para hindi magkakaroon ng yung high voltage or potential difference. Okay, Yasmin?
Okay. Thank you very much, sir. If you have any follow-up question also, Sir Nathaniel Guevara, you may raise your hand. Okay, so next question is from Sir Jervin Tagpuno.
Hello?
Hello, sir.
Yes, can I add something? Doon
Yes,
sa
sir. Sure, sir.
earthing grounding system. Yung kasi tinatawag
Okay po,
na
sir.
multi-pole earthing, normally sa distribution side, no? Hindi doon sa installation side, ano? Actually, meron tinatawag na single source earth return, no? Yung SWER na tinatawag, which is very common sa mga utilities natin sa mga ibang so they have to earth. Tama yung sabi ni Charles na we have to have a equal potential, ano? Pag mahaba masyado yung distribution line. So ang nasa code kasi natin PEC, it's every 400 I think meters na makakaroon ng grounding yung bawat poste. That is the purpose of which is to have equal potential, ano? Yung voltage rise nila hindi pare-pareho lang sila along the network. So yun yung tinatawag na multiple earthing system. It's not actually related to the low voltage, ano, application. It's more on the distribution, yung side, ano, ng mga utilities. Yun lang. Kung I think yun ang main isang reason.
Okay, thank you very much, Sir Conrad. Once again, if you have any follow-up question regarding this, you may raise your hand or type it in the Q&A box. Next is from Sir Jervin Tagpuno. Electrically connected po ba dapat ang neutral bar at grounding bar even after the main panel?
Yeah, Jervin, doon sa natin, Jervin, yung laging ina-explain ni Kwan pag umattend ka, yung grounding and banding ni Engineer Jaime Mendoza. So, pag nag-band ka na sa source, huwag ka nang magbaband doon sa Kwan mo, sa mga distribution panel mo. Yun din yung na-explain kanina ni Engineer Conrad. So, kasi magkakaroon ka ng yung spray, yung Kwan mo, may circulating current ka doon sa Kwan, sa panel board side pag dalawa yung banding mo. So, kung ang banding mo sa source, doon ka lang. Okay na yan. Para kung merong kang ground fault o kaya merong kang sumayad na low insulation yung isang cable mo, makakabalik yung yung fault mo doon sa source. Okay, Jervin?
Okay. In addition to that, I want to give you one practical example. Na sa isang installation ito, no, based on the experience when I conducted an audit, tama yun, we have only to band it, ano, dun sa natin sa distribution, dun sa IEC kasi distribution side or sa MDB, no? Kapag naghiwalay na sila, nagiging TNCS, no? Separate na yung neutral at saka earth mo, hindi mo na dapat siya i-connect doon sa panel boards beyond the main distribution board. Kasi ang mangyayari niyan, magkakaroon ng tinatawag na objection sa PEC, it's called the objectionable current, no? And this objectionable current, kung meron kang earth leakage protection, kunwari nandun sa sa main mo, no, meron kang protection doon ng earth leakage, magugulat ka na lang, magsha-shutdown ka, hindi mo alam ang dahilan. Bakit? Kasi meron kang circulating current, yung tinatawag ni Charles kanina. It was actually objectionable current. It will cause tripping, ano, yung mga sensing mo sa sa mga protective device mo pag meron silang mga ground fault or residual monitoring. So, yun magiging disadvantage. Okay? That's all. Okay.
Okay, thank you very much po. Next question from an anonymous attendee. Bakit po inaalaw ang paggamit ng 2-pin na na convenience outlet dito sa Metro Manila, whereas we use line-to-line system.
So nasanay na tayo sa 2-pin, no?
Okay. Oo.
Yeah, sige, Engineer Conrad, ikaw na, Engineer Conrad.
Okay, let me address that ang 2-pin, ano? And ginagamit 'yon pag meron tayong tinatawag na double insulation, no? Kung makikita mo yung mga devices natin, yung mga kunwari meron kang cellphone o yung mga mga charger mo, okay? And makikita ka ng double square kasi sa product standards, meron kang double square. That is what we call a double insulation. So ina-allow 'yon kahit na wala kang earthing, no? Wala kang earthing. Doon wala kang protective earth, basta double insulated yung pan mo, yung ginagamit mong mga cables, yung device, yung cable doon sa adapter mo is rated siya as a double insulated device. So ang mangyayari niyan, doon sa outlet mo, dalawa na lang, no? Ang pan mo doon, 2-prong na lang. But actually ang requirements diyan kung hindi double insulated, dapat meron kang earth talaga. So kailangan gagamit ka ng 3-prong doon sa pan mo, sa out mo. Otherwise, makakaroon ng issue ng shock, ano? Kapag nagkaroon ng insulation fault yung device mo. So justify mo naman 'yan, ano? Sa IEC kasi sa protection against electric shock, meron kaming tinatawag diyan na indirect protection saka direct protection. Then of course gagamit ka ng yung kasi yung direct, merong mga tinatawag natin mga double insulated, ano? And it's one of the way of protective measures against electric shock. Okay?
Saka pag nagpa-renovate tayo ng bahay, gawin na natin yung 3-prong na para maglagay tayo ng equipment grounding conductor para yung green wire ng washing machine natin o kaya appliances natin, di lang naka-float. I-ground na lang natin.
Anyway,
safety.
In addition, dun sa standardization na ginagawa namin, we have already submitted to IEC, those in charge na yung technical committee in charge of the sockets, configuration. So nilabas na namin yon, pinadala na namin doon as a country note kasi dapat malaman natin kung ano talaga yung ginagamit natin kasi dito sa bansa natin. Ang daming configuration, di ba? Iba-iba. So malaking problema to. So actually this one is through the BPS sa consumer protection and protection against electric shock. Doon dapat ma-implement yung proper configuration ng mga outlet, mga sockets dito sa bansa natin. Pero we're working on this one, so hintayin lang natin kung kailan maging mandatory ito. Okay? Thank you.
Ayan. Okay, so for the next question po. Okay, from Sir Danny Dave Fabiania. I have worked in a healthcare facility before. The system is YY grounded. Why do we recommend for hospital to have a delta load side?
Yeah, Danny. Okay. So, yung na-discuss ko kanina at na-discuss din ni Engineer Conrad, yung delta kasi, pag may fault, ungrounded kasi yun eh. Pag may problema yung isang line mo, di ka pa rin magti-trip. So, yung mas reliable pa rin yung power supply mo. Hintayin mong magka-problema ka sa ibang line bago ka mag-trip. So that's the reason why na siguro yung mga ibang very important facilities, delta ungrounded yung ginagamit nila for reliability. Pero kailangan mo maglagay ng mga monitoring mo doon para makita mo kung meron ka ng fault. Yung pinakasimple, yung naglalagay sila ng mga ilaw eh. Na pag normal, pare-pareho yung brightness ng ilaw. Pag may sayad yung isang line mo, nag-iiba yung liwanag ng isang ilaw mo. So yan ang kanya reason niya.
We also have a follow-up question from Sir Danny Dave Fabiania. What is the advantage of delta grounded to delta ungrounded?
Yun nga, yung pag
Okay.
ungrounded system ka, mas yung reliability. Pero
Yes.
problema mo yon pag hindi mo na-detect kaagad. Kasi magkakaroon ka ng mga unstable voltages na tumataas. So nakakasira ng mga insulation yon. Unlike yung grounded, pag may fault ka, mataas yung current mo, nakikita ng protective relay mo. Ititrip niya kaagad. So yun lang yung pinagkakaiba ng ungrounded sa grounded system. So yung ungrounded, yan ginagamit sa mga pag ayaw mong magkaroon ka ng nuisance sa tripping o kaya gusto mo kung pa rin tuloy-tuloy pa rin power supply mo kahit may isa kang fault. So yun lang yung difference niya.
Okay, the next question is from Sir Christian Argoncillo. Sir, as per my experience, when the contractor forgets to ground the neutral connection of the transformer, during voltage testing, the phase voltages are not equal and has voltage difference of almost 30 volts per phase. Bakit po kaya?
Yeah, yun yung tinatawag na floating voltage. So yung neutral mo naka-float kasi may imaginary capacitive ka ngayon capacitive grounding. So yun yung nagiging reason na nagkakaroon ka ng pag sinukat mo yung line 1 to ground, line 2 to ground, line 3 to ground, matataas. Wala kang na-establish na grounding connection mo sa neutral. So nagkakaroon ka ng high impedance to. Yung high impedance mo yung capacitive connection mo to ground. So delikado yan, nakakasira ng kanyang mga equipment. So wag niyong kakalimutan lahat ng mga projects niyo kasi kung minsan nakakalimutan ng mga contractors na i-ground yung neutral ng transformer na Y. So do not do that kasi mas marami yung masisira mga equipments natin.
Thank you very much, sir. Next question is from Sir Nathaniel Guevara. Does the isolated power supply system considered ungrounded system?
Depende yung isolation transformer mo na gagamitin. So kung delta secondary, kung hindi mo intention na i-ground yung corner ground, so ungrounded yon. Pero kung yung isolation transformer mo is Y secondary, dapat naka-ground yung neutral mo. So depende yung gagamitin mong isolation transformer. Okay, Yasmin?
Okay, sir. Next question is from Sir Nelson Jr.
Na-disconnect si Yasmin.
Hello, sir.
Yeah, we can hear you, Yasmin. Go ahead.
Sir, next question is from Sir Nelson Benyares. In Gensan, our utility Socoteco 2 is using Y delta transformer banking for the source of three-phase supply. Is the owner of a facility can suggest to have its connection different from that of Y delta system since Y delta system is no longer used except for some special case?
Yep, Nelson, pwede mong i-question, Nelson. Pwede mong i-request sa DU na ayaw mong gamitin yung delta because of the disadvantages para bigyan ka ng supply na naka-Y siya. Kasi yung delta nga baka hindi sila mag-trip. Mas sa bagay, kung ka naman, kung may sarili kang substation, okay lang 'yon kasi meron kang magkakaroon ka ng delta Y na transformer Pero kung direct DU binigay sa iyo is delta, i-request mo na lang na i-Y na lang para pag may fault ka sa building mo, makakabalik yung fault dun sa Y nila para mag-trip yung protection ng DU.
Hello, Charles.
Yeah, go ahead, Conrad.
Yes, using delta, it's mostly used in isolated system. Ang problema sa delta kasi, the moment you don't use any ground dun sa isang leg niya or center niya, makakaroon ng problema sa detection ng ground fault or earth fault detection. Okay, you can use it, but you have to add mga device pa, yung tinatawag natin na grounding transformer. And for a facility na kunwari commercial ka lang, hindi ka naman industrial process, additional cost sa iyo yun, yung magkakaroon ka ng grounding transformer. And that grounding transformer is just for the purpose of ground fault detection. Kasi kung wala ka niyan, saan babalik yung ground fault mo? Wala kang pupuntahan, di ba? So sa secondary, sa low voltage o sa installation side, palaging meron kang return path to ground, either na through an EGC or protective bonding conductor pabalik sa source, or through the earth, na meron namang continuous na PE na i-connect. Kasi kung wala yon, you have a problem, you have an issue on the protection measures para sa earth or ground fault protection. So kailangan talaga i-code mo siya. Kung pwede, i-request mo na magkaroon ka na lang ng Y, or grounded Y, mga ganun. Or delta, pero i-ground mo yung isang leg mo para mayroon kang detection sa ground. Okay?
Thank you, sir. So for our next question from Sir Filomeno Ducay. Sa single-phase two-wire system ay madalas na nagkakaroon ng kalituhan kung ano talaga ang prefix name nito. Line to ground ba or line to neutral system? Madalas kasi na hindi daw kailangan maglagay ng equipment ground conductor kasi line to ground na daw ito. Ano ba ang dapat na tawag dito para maiwasan ang kalituhan? Mahalaga kasi na magkaroon ng EGC ang instalasyon. Yun po.
Yeah, ito yung two-way system versus three-way system. Yung two-way, yung pala mo, yung single phase two-wire mo, yung line isang line mo, yun yung live, tapos ground yung line to mo. So line to ground. Okay? Pero with that installation, kasi carrying conductor yung dalawa yung line 1 and line 2 mo. So kailangan mo pa rin ng equipment grounding para sa protection mo naman dun sa mga appliance mo, saka yung internal installation mo sa bahay. Yung naman, yung three-wire system, since ginamit mo yung neutral na, so yung 115 o kaya 110 volts, yun ang line to neutral. Tapos yung line to line mo, yun yung line 1, line 2. So line to ground para hindi ka na malito. Line to ground kasi hindi naka-float yung neutral mo on that one, yung two-wire system. Pero kailangan mo pa, very important pa rin yung equipment grounding. So kung bahay mo yan or magpaparenovate ka, yan, iligay mo yung equipment grounding mo para safe. Okay, Yasmin.
Okay, sir. Thank you very much. Another question from an anonymous attendee. For freezer or ACU loads, pwede ba nating gamitin ang GFCI as a replacement for convenience outlet? Gusto ng owner GFCI ang gamitin dahil kaya naman daw sa budget. Wala ba tayong iba violate na code dito?
Yeah, mas maganda kung may budget. Bigyan mo ng GFCI. Yung PEC natin, sinasabi na ko yung PEC natin, may mga provisions, yung mga wet locations, yung bathroom mo, yung cooking area, tapos yung outdoor mo, dapat naka-GFCI ka. So para pag may line to ground fault, nakikita niya kaagad yung fault, yung unbalance. So kaya para mag-trip ka agad yung outlet. Yung mga condominium, yung mga ngayon, naka-GFCI na yung kanila, mga bathroom, tapos yung mga sink, yung sa malapit sa mga kanila lababo. So requirement nasa PEC na natin 'yan. Pero maganda mas maganda kung ilagyan mo lahat kung may budget para safe. Okay.
Okay, sir. Next is from Sir Nathaniel Jan Torre. Sa Y-to-Y transformer, ano po ang advantage and disadvantage ng bonding ng primary and secondary neutral sa grounding? Recommended din po ba ito? If banded po sa transformer yung neutral at ground, meron po kayang voltage reading ang phase to ground? Salamat po.
Yeah, yung YY ngayon, pag si Meralco kausap mo, baka hindi ka payagan na mag-YY eh. So require niya talaga yung delta Y. For the reason, yung reason nila na pag merong kang line to ground fault doon sa building mo, hindi lalabas sa system nila. Kasi yung line to ground fault mo, iikot lang sa delta primary. So number one yon, number two yung mga triplet harmonics yung pinapakita ko kanina. Pag may marami kang harmonics o non-linear load sa loob ng building mo, so yung mga triplet harmonics mo, magre-reflect lang dun sa delta pero iikot lang sa delta. Pag naka-YY kasi, pag may fault ka dun sa natin, line to ground fault dun sa secondary, lalabas dun sa DU, dun sa Y primary yung fault. Dun sa reason why yung mga DU hindi na pumapayag. I do not know kung may mga DU pang pumapayag sa YY. Tapos yung experience namin, yung YY na binad namin yung primary sa secondary, nagkaroon ng objectional current, circulating current. So, yung pinapakita ko kanina, lalo pag may load ka, pwedeng yung Y mo sa primary, pwedeng dumaan din sa Y mo sa secondary. So, dapat i-isolate mo na lang yung banding mo for that. Huwag mong ibaband yung Y mo sa primary to the Y secondary. Okay, Yasmin? Nawala si Yasmin.
Hello, sir. Nawawala po yung...
Palipat-lipat ka.
Hindi maganda yung signal. Hindi maganda yung signal nyo. Palipat-lipat po si Yasmin.
So next question po, sir, from Sir Filomeno Ducay. From an anonymous attendee. Ang solderless connector po ba ay masasabing suitable mechanical connection? Common ko po ito sa pagband ng GEC sa grounding electrode. Baka lang po kasi nakasanayan na lang siya gamitin tapos di naman po pala suitable.
Yes, suitable naman siya. But the main thing with using solderless connection, kapag nakabaon na ito sa lupa, no, especially considering that it's in the soil, so mahirap yung maintenance mo dyan. Maganda lang yung solderless connector pag naka-expose. So you can maintain it, you can conduct maintenance on retightening, on checking. So malibit kasi sa grounding or earthing systems na it's in the concrete, already embedded in the soil. Kailangan exothermic welding ang kailangan. So meron siyang certain applications, okay naman siya, basta maintain mo lang siya, meron siya lang checking, verification after years of using this solderless connectors.
Sir, for our next question from Sir Filomeno Ducay. Open secret na madami na sa ating mga electrical installer ang naglalagay ng grounding electrode na dedicated lang sa mga aircon at mga refrigerator. Meaning, self-grounding na hindi banded sa power system grounding either sa 2-wire or 3-wire system ng utility or cooperative. Effective po ba ito sa ground fault condition?
Sorry to say, again, kanina binanggit ko yan, it's a violation of the code. Ang kasi, priority, kanina binanggit ko about, hindi lang yung aircon, yung electronic equipment. If it violates the safety of a person, hindi pa pwede yun. So, ang gagawin dito, dapat i-band lahat, papunta sa source, sa earthing, doon sa main earthing terminal. So, kung meron yun, I don't know, kung later meron kang ground fault sa aircon mo, when you have an unearthed system, ibig sabihin yung ginagamit mo, yung soil, hindi siya effective, ground path for the ground fault. Hindi ganun ka-effective yun. At makikita naman natin yung problema. Makakaroon ka ng electric shock. So the only way is to install an EGC. no? Protective earth banding doon sa aircon mo, sa body niya, papunta doon sa source mo. Okay? So we have to be guided by this rule, yung requirements ng code, tsaka yung practicality, walang pupuntahan yung fault mo pag doon ka lang pumunta sa earth na yon. And the condition, we don't know kung ano yung resistance, no, of the earth. Okay? Especially pag mataas yung impedance na yan, magkakaroon tayo ng problema sa protection against electric shock. Okay?
Okay, sir, next question is, what is your recommendation that is best suited to PH industry, IT or TN system?
Come again?
IT or TN system po. What is your recommendation that best suited to PH industry?
PH?
Philippine industry po, Philippines. Sa recommendation na best suited po sa PH industry, IT system.
No. We have to understand that earthing system can both exist on one installation, no? But you have to be very careful in using this one. For example, the TN system, yung kanina, yung grounded system, very specific yung applications niya. If you want to have a ground fault detection, yung magkaroon ka ng yung perform yung mga overcurrent protective device mo, you have to use the grounded system, yung TN. Then if you want to use the IT, wherein you want to have a continuity of service, no? Ayaw mong magkaroon ka ng power interruption on ground fault during the first fault condition, ayaw mong magkaroon ka ng interruption sa facilities mo kasi maka-epektuhan yung production mo, then you have to use the IT system, no? So doon sa isa, yung TT, may kanya-kanyang application dyan. Ang very common sa atin dito, application natin is TN. Yung IT, merong special applications yan. Like for example, we have mentioned yung mga facility, yung mga healthcare facilities, no? Yung mga industrial plant, smelting plant, yung mga process na ayaw nila magkaroon ng shutdown sa first fault. So they have only to monitor this. So ganun ang application nyo. There is no such thing as yung super, yung isa sa isa, no? Hindi ganon ang earthing system. You have to really to know yung application, depende sa yung paggagamitan mo, yung application nga nung mo, ng earthing. Okay?
Okay, next question, sir, from an anonymous attendee. Pwede po pa-discuss in simple terms bakit delikado ang objectionable current sa mga large establishments na may multiple panel and sub-panels?
Kanina nabanggit ko kasi kung meron kang dumadaan na current doon sa earth mo, what will happen if you have a detection, no? Ground fault detection or residual earth fault protection, matitrip yung magkakaroon ka ng tinatawag na nuisance tripping. Supposed to be ang return current from the lines ay neutral ang ginagamit. It will return to the neutral source, no? So yun yung patch. Kung meron kang objectionable current dumaan sa earth, ano mangyayari niyan? Dalawa, magkakaroon ka ng tawag dito yung sensing, yung monitoring ng earth fault or residual ground fault protection mo. Mag-o-open siya and it will interrupt unnecessarily. Pangalawa, pupunta sa earth yung kwan na yon, objectionable current, mangyayari, makukuryente ka. Pag hinawakan mo ngayon yung body o whatever na equipment na dumaan doon yung kwan mo, yung objectionable current, you can calculate that na ikwan mo yung paa mo or nahawakan mo, no? Hindi ka insulated, makukuryente ka. It will cause electric shock. Okay? So yun ang magiging problema mo rito.
Nawala uli si Yasmin.
Ngayon, dalawa na.
Hello, sir. Ayan.
Meron bang additional, aside from the 2 points, yung third point, yung kanina, yung objectionable current, interference, ano, sa mga kwan mo, mga signals, communication. magkakaroon ng effect yan. Kasi magkakaroon ng stray current na tinatawag. Katulad yan, maliban na minsan merong mga sound system, di ba? Sa mga tawag dito, mga events. Napakalakas yung hum ng sound system. Kasi merong yung earthing, yung merong siyang current, no, dumadaan dun sa earthing. So nakakaroon siya ng problema dun sa mga PA systems, no. So isa 'yon, no, sa communication, magkakaroon siya ng effect, no, performance niya. Okay?
From Sir Jervin Tagpuno, what are examples of nonlinear loads sa commercial and industrial loads?
Yung mga variable speed drives natin, tapos yung mga elevators mo na inverters, escalators na inverters. Kasi karamihan ngayon ng controls natin more on na mga inverters. Yun yung yung reason kaya nagkakaroon tayo ng mga harmonics, yung mga nonlinear loads na yan. So more on mga karamihan electronics na kasi natin ngayon, mga controls. So yun yung nonlinear loads natin.
Okay, next question po from Sir Charles. From Sir Delphine Tapia. What do you recommend po the best method or common practice of installation for Delta Y transformer 400-volt system? Thanks in advance.
Ano yung question? Anong may
What do you recommend po the best method or common practice of installation for Delta Y transformer 400-volt system?
Pwede bang ma-request natin si Engineer Tuan to
Sir
elaborate?
Tapia, if you are with us, we will try to unmute you po, sir, and you may yes, unmute. Ayun po, naka-raise po siya ng hands. Hello, Sir Delphine. You may unmute your mic po.
Hello, sir. Good afternoon po, Sir Charles.
Good afternoon, Delphine.
Sir, you discussed a while ago, sir, regarding this different methods. Actually, sir, may mga magandang mga din, sir. May city, iba naman parang typical lang na grounding and bonding ng neutral saka ground. So I think yung last part po, sir, yung parang sabi niyo po na prepare common na ginagamit. Ano ba yung
yung residual sensing method, Delphine?
So yung mas parang best practice na common na pwedeng gamitin compare sa others.
Yes, Delphine. Yan ang pinaka-simple way. Kasi nakakuha ka naman for pole ka dun sa mga main mo. So, yun ang pinaka-the best na protection mo for the 400-volt system. Yung residual sensing method.
Yes po. Thank you po, sir. Yung residual.
Saka very important sa 400 volts. Yung bakit ka for pole dun sa main mo o kaya sa ATS. Ang reason nun, para pag naka-normal ka, yung neutral mo is in reference dun sa neutral ng transformer. Tapos pag nag-brown out, yung reference mo ngayon dun sa load mo is, yung neutral mo is in reference na sa generator. That's the reason why yung ATS mo is 4 pole. So huwag ka mag-triple dun sa mga ATS natin. Dapat magkaroon ka ng separately derived system pag 400-volt system ka.
Thank you po, Sir Charles.
Thank you.
Po, para po sa mga nag-raise ng hands kanina, ni-lower lang po muna namin yung hands ninyo. And if gusto naman po ninyong magsalita, kindly raise it po now. Kasi yung iba po, pag mini-message ay napipindot lang daw po. So now may nag-raise si Sir Renato Arancon. We will unmute you po, sir. Hello, sir.
Yeah, thank you very much. Mayong hapon.
Mayong hapon, sir.
Naalam ko I would like to ask question on the calculation of neutral current. Just
yes, sir.
To clarify on this regard, kasi po for the condition of unbalanced condition, the computation of the neutral current is actually based on the application of Fortescue's theorem, yung symmetrical components.
Tama.
And so it is very clear that the formula says that the neutral current is just equal to 3 times the zero sequence component current. Tama?
Yung neutral current is 3 times.
The zero sequence current. Tama po?
Baka kung kwanto, pag may ground fault ka.
Hindi po. Yun ang ano,
Okay.
balance condition, ano? Kasi unbalance kasi yung kuryente na pinakita mo kanina sa quiz.
Yeah, tama.
Oo. Otherwise, it would have been stated na harmonics due to harmonics. So ang computation ng neutral current should be the square root of the square of the third, the ninth, and all those multiple of 3. Ano? Otherwise, kung tripling harmonics po, it should start at 9.
Yes.
Po, no? So I was just medyo i-clarify ko lang kasi if it is really an unbalance, purely imbalance in general, then in fact it has also pointed out from the reference na I got that the neutral current should not be less than the phase value. So kasi ang nangyari 22.19 and then the phase value is more than 100, ano?
125 yung line 1, line 2 150, line 3 is 130 by 130.
Correct po. Correct.
So may unbalance ka ngayon. May unbalance current ka.
Yes.
So napunta sa neutral yung unbalance current, which is pag kinompute mo siya 22.91.
Hindi po mangyari yun kasi it has to be applied by Fortescue's theorem, which says that the neutral current should be 3 times the zero sequence current, no? If you look at the consult the book of Paul Anderson, nandun po yung derivation po yun sa you can even consult the power system analysis by John Granger or Stevenson. Basta ma-discuss yung symmetrical component, Fortescue's theorem. Yun po ang derivation ng value that I sub n should be equal to 3 times the IAO or the zero sequence current. So ganun po nangyari. So
Okay. So ito nga yung pag nagko-compute ka ng line to ground fault. Ito nga yung sinasabi mo. Pag may line to ground fault ka, ito na yung in-explain mo. Ito kasi yung unbalance to eh, yung sinasabi ko kanina, unbalance. Pero yung line to ground fault mo, kasi pag may line to ground fault ka, that is zero sequence. So sa neutral siya babalik.
Opo.
Yung zero sequence.
May ground fault ka yan. Tama po yun.
Yeah, tama. Yan yung siguro yung sinasabi mo naman.
Okay. So, medyo na lang ako,
derivation.
Na-clarify ko lang yun.
You understand na, tama. Tama yung zero sequence. More on fault calculation.
Pero hindi naman nakatalaga doon yung yung grounding. Wala namang grounding. Or kasi ang nakatalaga lang doon is yung value ng current that flows sa 3 phases.
Yes.
You asked to determine how much would be the current that will flow to the neutral.
Yeah, tama. Oo. Kasi kung i-compute mo doon sa formula mo, ano dapat lalabas?
Ano talaga, sir? It should be a sum of these 3 fault current.
Hindi pwede mangyari yun, sir, Donato. Hindi pwedeng mag-triple yung current mo. Hindi times 3. Kasi unbalance yung mo.
Kasi kung itin mo naman sa formula mo na the square root of the sum of the squares and plus ano ba yun? And then yung nakabase doon yung unbalances ng kuryente po sa per phase is due to harmonics presence, tama ba?
Iba yung po, sir. Iba yung slides noon. Yung dalawa kasi yung questions ko kanina, itong question na to, yung unbalance. Tapos yung pangalawa, yung disadvantage, yung isang drawback of 400 volts na pag may triplen harmonics ka, magkakaroon ka ng tataas yung current mo dahil mag-a-add up yung triplen harmonics mo. Baka yung sinasabi mo, yung mag-a-add up yung triplen harmonics.
Yung sagot na 22.19 amperes.
Yes, oo, unbalance 'yon. Yan yung kanya talaga. Hindi mangyayari na yung unbalance mo magti 3 times ka sa phase. Hindi mangyayari 'yon.
Kasi
Yung
sa
one,
size tayo, kaya nga, magsa-size daw ng size ng neutral current, it should be 3 times the face value.
ay walang siguro hindi mangyayari yan yung kung sa neutral current lang.
Clarify ko lang kasi
Tama.
so paano yun na source, sir? Paano yun nakabase yung formula na yan?
Yung sa unbalance niya, unbalance. Kasi pag kung may unbalance ka kasi sa line 1, line 2, line 3, saan pupunta? So babalik lang siya sa doon sa neutral kan pupunta. Kaya nga ko yung mga 400 volt system natin, pag nag-measure ka, even yung mga club tester, mas mababa lagi yung neutral current mo. Tataas lang yan pag nagkaroon ka ng triplen harmonics. Tulad yung na-explain ko kanina na meron kami isang case na mas mataas yung neutral current dun sa phase current. So what we did, naglagay kami ng in-isolate namin yung load na nagki-create ng high harmonics, may isolation transformer. When we did that, naging normal na yung neutral ng system. Mababa na siya. So yun lang, baka nalito lang kayo yung parang yun na-explain nyo more on yung short circuit calculation, line to ground fault talagang yun na, yung zero sequence yung pinag-uusapan dyan pag line to ground fault.
Kasi nagabase lang ako, sir, sa Fortescue's theorem,
Yeah.
So, unbalanced condition, each spacer will be represented by 3 sets of balanced spacers. So,
baka ibang kan na ngayon, computation.
I-apply mo yun with that concept of unbalanced conditions sa system, you will end up with that expression. Hindi ko lang ma-proceed kung saan ang galing yung formula na yan.
Yeah, pero yung actual installation hindi mangyayari yung 3 times. O hindi mangyayari. Pero ito, talagang tested to yung formula na to. Kahit nag-measure din kami ng yung true PQA.
Based on measurement, actual measurement.
Yeah, lalabas talaga yan.
Kasi mas maigi sana kung ma-explain yung nasaan ang galing yung formula na yan.
Yung derivation. Anyway, sige. Next ko natin yan.
Kasi para at least ma-justify yun ba, di ba? May mga
that's right. Okay.
So, yun lang po, Sir Charles. I am so grateful po sa inyo.
Thank you, Gironato. Thank you.
Salamat po.
Okay, Yasmin.
We also have Sir Noel San Buenaventura who also raised his hand. Sir, you may unmute now. Ayun, napindot lang po yata ni Sir. Hello, Sir.
Yes, ma'am, napindot lang.
Okay po. Okay, sir.
Noel, meron lang akong input sa iyo, Noel. Baka may may mga yung pinag-usapan natin kanina yung mga grounding, yung mga down conductor papunta sa electrode mo. I-check niyo yung mga system niyo, yung mga buildings niyo. Baka yung down conductor nawawala na. Lalo pag copper ninanakaw yan, ha. Kaya
yes, sir.
Yung audit, chine-check natin yung mga down conductor doon.
Yes, sir. Thank you po.
Thank you, Noel.
Okay, for our next question po, ito po. From Sir Jonar Tamboong. Hi, sir. Is it acceptable if ipapadaan ko ng circuit breaker yung neutral conductor?
Okay. So, kung ang application mo is yung sinasabi mo is yung panel board mo sa lightings, dun sa mga outlets mo, wag mo nang lagyan ng breaker yung neutral kasi mas magandang mas magandang continuous, yung wala kang isolation dun sa neutral. Hayaan mo na yung yung nasa main mo, yung sa ATS mo ang nagkakaroon ng isolation. But for the single phase loading, gumamit ka lang ng single pole. Tapos yung neutral mo, yung cable na lang yung wala ng isolation. Mas better 'yun.
Thank you very much. Hope that answers your question, Sir Jonar. Next is from an anonymous attendee. Is there any problem or is it a good practice to have an equipment grounding conductor bonded in the service equipment to the neutral and grounded through the electrode for a single line to ground system which is a usual system in residential in the province distribution utility.
Dear Conrad, ikaw na? Dear Conrad?
Apo.
So, yes, what was the question again?
Okay. Is it a good practice to have an equipment grounding conductor bonded in the service equipment to the neutral and grounded through the electrode for a single line to ground system, which is a usual system in the residential in the province distribution utility?
Yeah, yes, that's right. If you have a single phase transformer, one is line, the other one is ito yung misconception sa line and neutral, line to ground. Depends how you use the other phase. Kung gagamitin mo siyang line 1 yung isa neutral, it means to say that you are going to connect a load to the neutral. Yung iba naman, line to ground kasi ginagawa nilang grounding din. Then, it's correct na gumamit ka ng EGC. Naka-ground yung neutral mo sa grounding electrode and you can use the same, yung neutral na yon papunta dun sa load mo. And that's a good practice. Ngayon, kung nilagyan mo pa ng additional EGC, it's much better. Nagkakaroon ka na ngayon ng tinatawag na TN system siya. Nagkaroon siya ng TNS. Common neutral, ground. Then nagkaroon ka ng separate na neutral. Nagkaroon ka pa ng EGC. Then it will give protection during ground fault. Lalo na sa personal protection. So may babalikan talaga yung yung fault mo to protect the person. Okay? So yun malimit ang ginagamit sa province talaga. I-ground mo siya yung neutral mo. And then at the same time you can connect EGC to that grounded neutral. Okay.
Okay, thank you very much, Sir Conrad. One of the members of this TCPDC is raising his hand. So, Sir Jonathan Medalla, you may unmute your microphone, sir.
Okay, good afternoon, everyone. Thank you, Ma'am Yelo, for acknowledging me. And good afternoon, sirs. So, sir, actually, I'm not sure if yung transformer configuration or transformer banking na Y grounded primary and delta secondary na-discuss ba kanina and what's the impact? Kasi I'd like to share one of our experiences also. I don't know kung we have the same perception, sir. May gumagamit ba niyan na na ganyan na transformer configuration or banking, Y grounded primary or delta secondary?
Y delta?
Y grounded primary, delta secondary.
Sa distribution, sa amin sa application
Distribution namin. Transformer po, sir.
Hindi pa ako naka-experience ng ganun yung Y delta Y yan lagi. Pero doon sa yan, wala pa akong experience na.
Okay. Gusto ko lang kasi kung we have the same perception kasi may isang establishment po dito sa Davao na ganyan yung configuration, and then it would give impact or degrade yung distribution system kasi may recloser siya that serves the establishment, and then any fault na nangyari sa feeder sa distribution, palaging nagtitrip yung yung recloser or yung breaker serving that establishment. And then as found kasi sa sa banking ng transformer is grounded yung primary and delta yung secondary. It seems that that banking is grounding transformer ba, so naging path siya ng zero sequence current, and yun parang nagparallel yung distribution transformer for that establishment sa substation na grounded Y. So tinatanong ko lang kung we have in the same perception na yun yung magiging impact, parang naging grounding transformer yung niya, connection niya, connectivity niya.
Yung delta yung naging grounding transformer.
Yung Y grounded primary or 13.8 primary, grounded siya, Y, and delta secondary. Yung secondary, yun yung sa customer na side.
Yeah, oo. Kasi kung may line to ground fault ka dun sa Y, so dapat it would not affect yung pwede kasi iikot yung mo. Pwede mangyari yung affected pa rin yung delta dahil iikot doon yung zero sequence. Pag may line to ground fault yung Y, so i-reflect niya sa primary mo delta yung zero sequence, pero magsi-circulate doon. Pag nag-circulate doon, pwede rin ko yun, mag-iinit. That's the reason why siguro yung setting mo sa protection is pinitrip niya yung recloser mo.
I see, sir. Sige, thank you po, sir. Thank you po sa sir.
Yeah, thank you, sir.
Okay, thank you po, Sir Jonathan, for your question. Next po is from Sir Nathaniel Guevara. Suppose there are contradictions between PEC and the PNS IEC 603641-2020. Is there any committee to interpret and provide guidance of which standard would take precedence?
Hello.
Yes, Sir Conrad.
Can you repeat again the question?
Okay. Suppose there are contradictions between PAC and the PNS IEC 603641-2020. Is there any committee to interpret and provide guidance of which standard would take precedence?
Yes. As I mentioned a while ago, we have adopted the IEC 60364 as Philippine National Standard. This standard is a guideline only. It may be used by any technical committees, any electrical practitioners to guide them on their works. But in the foreword of this PNS standard, we have mentioned that PEC still prevails, the minimum standard requirements. So kung halimbawa, nakakaroon kayo ng issue, ginamit nyo yung IEC, yung PNS na yon, tapos nagkaroon ng problema, no? Hindi dapat darating sa point na yan kasi ang sinasaad namin dito sa PNS, still you have to follow the requirements of the code kasi yun ang legal documents natin eh. So hindi pa pwedeng gagamit ka ng iba, then you are using it, at lalo lang pag yan eh hindi, it's below the requirements of the PEC, makakaproblema tayo. So very clear yung forward namin sa PNS 60364-1 that is still the PEC prevails when it comes to technicalities. So magiging guide lang natin ito, we can use it only as a guide yung PNS na yan. Ang maganda kasi rito, the moment na we will study further this standard, pwedeng magiging input ito sa committee ng PEC to develop or to adjust yung standards natin kasi mostly ang PEC it's based on the National Electric Code. Every year nagbabago rin tayo. Pero nandiyan naman yung experts natin sa PEC committee wherein they studied the various like hindi lang IEC, yung meron ding UL yung ANSI, IEEE standards, nagagamit yan Ang role namin dito sa PEC 1-IEC is focus more on IEC para makita namin kasi yung similarities ng dalawa ng code natin tsaka yung standards. Then makikita rin yung difference. So sa ganon, ma-address natin kasi minsan may isang issue na nangyari during our discussion on BPS technical committees. Itong building official, there was an issue about the GFCI and using the 30 milliamperes RCD of IEC. Kasi nakalagay doon sa natin, sa code natin, sa Article 1 on GFCI is that you have to use class 1, yung UL class 1 GFCI, which is the 4 to 6 milliamperes detection, earthly case detection for personal protection yun, shock protection. Yan itong kinabit no itong isa, puro 30 milliamperes. So, siyempre, kung ako si Obo, ako yung mag-approve, then I always cite the requirements of the code, di ba? Hindi 30 ito ang nasa kwan natin. So, reject yan, di ba? But if you know about the standards, yung especially deep yung requirements ng IEC, why they put 30 milliamperes, makikita mo if you are versed of that, pwede rin pala yun na protection, no? It will protect both if there are 6 milliamperes or 30 milliamperes. On what premise? Dapat yun ang malaman ng isang electrical practitioners. So yun, sa susunod siguro, when we do some probably sa next siguro mga ng PAC, maaring magkakaroon na siguro ng depends upon the code, the committee, na magkakaroon tayo ng mga adjustment, modification, para sa ganun merong reference guide na. So for the meantime now, ang PNS is just guide, no, for our usage. Katulad ng kable, iba-iba yung size ng kable ng ISO, iba yung sa NEC o sa PEC. So nilalagyan natin ng parenthesis para yung equivalent, no, kasi maraming issue rin diyan when about approval, ano. Lalo-lalo mga consultant, yung mga natin, yung mga inspector, dinidisapprove. So all of us electrical practitioners should be aware of the standards. Yung difference niya. Walang compromise dito. There's nothing as compromise. It's about safety. We have to protect proper persons and properties and the use of this yung mga natin, yung mga sa low voltage installation, mga devices, and they are all related yung na ito, yung protection na ito. So that's it, ano? So ngayon wala pang arbitration. Kasi wala pa yan yung between PNS and it's just a reference. So tandaan natin, reference lang itong mga PNS na ito. Still, PEC is what we have to, yung mandatory requirements, na minimum requirements is being implemented in our country. Okay? Thank you.
Thank you very much po, Sir Conrad. So for our last two questions, this one is from Sir Danny Hamero. Sir Conrado, ask ko lang po, in our facility, TNCS po ang system namin, banded kami ng LVSG namin. But we have new equipments, electronic siya, nakalagay sa built-in panel board niya ay PEN system ang required nila. Ano po ang need namin gawin to address the requirement ng equipment namin?
Come again, ano yung system sa equipment? PEN? PEN?
PEN system ang required nila nung nasa... Opo. Ano po ang need namin gawin to address the requirement ng equipment?
Then you have to be very careful, ano? In a 5-wire system, PNCS, never connect, no, any equipment or any device na magko-combine muli yung dalawa, yung neutral at saka yung earth, because it will create yung tinatawag natin objectionable current. So you must be very careful in using that. So ang dapat gawin dito ay of course the equipment itself, maaari mong dalhin yung equipment mo, i-connect mo dun sa bandang source, no? Before the separation of the yung pen mo, no? Okay? Because kung sa utility ka, ang supply mostly ng ating utility is PNC dito sa Pilipinas. So dun sa MDB o sa main switchgear, naghihiwalay na. Meron kang pen doon, so naghihiwalay na siya. Okay? Neutral and earth. So dapat continuous ka na. So yung equipment mo, doon mo i-connect sa kung saan ka nanggaroon ng pen. Okay? So that's the only way how to solve this. Huwag kang mag-connect doon sa mga panel board o sa mga distribution boards. Doon ka kumuha ng connection doon sa switchboard mo kung saan meron kang PEN. Okay? Thank you.
Thank you very much, sir. For our last question from Sir Filomeno Ducay. Tama po ba na multi-grounded neutral ang distribution utility installation na TNC system hanggang kilowatt-hour meter? Then, magiging TNCS system na mula sa service equipment papasok ng ano ba tong DB? Pakiklaro daw po, sir. So,
actually, ang system natin is TNC, maging single phase man ito or 3-phase, ano. Yung multi-earthed system, it's not related to the low voltage. Ang multi-earthed system is related to the kanilawan ako, the medium voltage, no, side. Ito yung SWER, yung source return, ano, earth return. Ito yung sa maglalagay ka ng maraming grounding rod every 400 meters, yung requirements ng PEC, na makakaroon ka na para ma-equalize mo yung potential. lalo pag mahaba yung distribution mo. Now, dito sa secondary natin, it's actually TNC, yung system natin dito. And if you wire it, magiging TNCS. So, allowed naman yan. So, ganoon ang magiging setup natin. TNC, okay, if you want to use a separate PE para sa protection, which is needed, you have to run a separate yung protective earth o yung EGC mula dun sa source. Ano? Then the neutral, pwede mong gamitin as line to neutral. So magkakaroon ka pa rin ng protection. The moment you have a fault, dun sa line, isang line mo, pumunta ng ground, so the path it goes to the what we call the EGC, yung grounding protective grounding earthing conductor. Yung neutral mo, it's always used for return nung yung normal current mo going to the source. So yun, magiging yung purpose ng dalawa, yung neutral at saka yung earth. Okay? Thank you.
Yasmin?
Yes, sir.
Yeah, last question na pala, no? Meron lang akong dalawang inputs. Okay.
Yes, sir.
So, kasi meron na rin akong experience sa distribution, yung doon sa kasi may isang property na kami yung DU sa loob. So, tama yung Engineer Conrad na every 400 meters yung pole mo may may yung neutral mo naka-ground mo. Huwag mong gagawin yon pag malalapit. Huwag mong gagawin kasi magkakaroon ka ng stray current doon sa pag malapit yung neutral mo dadaan sa kanya sa lupa, pabalik sa kabila, delikado yon. So yun lang yung para mag-stable yung equipotential mo, yung mahaba lang ang natin installation. Pero ginagawa kasi nila every pole linagyan ng neutral grounding, huwag gagawin yon, delikado yon.
Tama.
Tapos number 2, doon sa 400 volt system 5 wires, lalo pag high-rise building yan, example yung isang floor, wala kang color code ginamit mo yung neutral is yung example yung green sana is para sa equipment grounding mo or sa IEC yung earth mo yon. Yung equipment grounding mo ginamit mong neutral. Tapos doon sa naman sa isang floor, yung neutral naman ang ginamit mong neutral. Delikado rin yun. Kaya very important na may color code yung mga cable natin para hindi tayo magkamali kung ano yung gagamitin nating neutral sa equipment grounding. Kasi gagana naman yung outlet mo kahit line to ground mo, 230 pa rin, line to neutral, 230. Magkakaproblema ka lang doon ng stray current uli pag nagkabali-baliktad yung gagamitin mong neutral sa equipment ground. So very important yung color code pag nagkaroon tayo ng mga installation na 5-wire system na 400 volts. Okay, thank you, Yasmin.
Going to Charles color code, siguro, probably in the near future, probably we could establish yung standard natin sa Philippines. Meron na sa code natin, pero minsan marami nagtatanong. Depende raw sa designer, depende sa application mo, kung ano yung code. So, mix up ang code na nangyayari. Minsan, pwede kang gumamit ng isang color lang, pero you have to put some what we call identification, doon sa dulo ng wire. Pero katulad ng ibang bansa, like USA, they have standard ng color, Sa IEC, merong standard. So, sa British standard, meron din yung RYB, di ba? So, dapat dito sa atin, siguro magkaroon tayo ng isang color din, Para sa ganon, the advantage of this, it will be a guide sa lahat ng ating mga electrical practitioners, and also sa manufacturing side ng cables, talagang mas madali na sa kanila yung mag-produce ng mga cables na may color, para kasi standard na ito eh. So siguro ganon na magiging direction natin, magkaroon tayo ng isang comment lang ito ng proper yung kasi hanggang ngayon marami nagtatanong ano yung color ng natin, di ba? So yun lang, isa sa mga recommendation sa susunod nating mga gagawin sa code natin. Thank you, sir.
Okay. Thank you very much, Engineer Conrado Binondo, Engineer Charles Singson, and also to Sir Jesse Santos for gracing us with your presence today and for sharing your knowledge to our participants on this Independence Day. Now, since we already awarded your certificate, we would also like to acknowledge the presence of Sir Alexander Ko, our CPD monitor, and also we would like to call on once again Sir Max Adarlo to present our certificate for Sir Alexander.
Institute of Integrated Electrical Engineers of the Philippines Incorporated, provider accreditation number OEE-2020-007, present this certificate of appearance to Engineer Alexander Dico for monitoring the CPD activity / program entitled Effective Grounding on 400-volt System, Fire Pump Code and Intent, IEC and any provisions on banding and grounding, held on June 12, 2020 via Zoom video conference. Issued this 12th day of June 2021 via Zoom video conference, signed by John Oliver G. Palad, CPD Coordinator.
Thank
you,
you
Sir
very
Max.
Okay, thank you very much po, Sir Max, and thank you very much po, Sir Alexander. May we ask you po to turn on your camera so we can have a picture with you accepting your certificate of appreciation, sir?
Okay po. Ito po, ma'am.
Thank you very much po. So, you may smile now, sir. 1, 2, 3. For a while, sir.
Parang di ko nakita, Yasa.
We will have a separate photo op, sir, but this one is for the acceptance of certificate for RCPD monitor po. Okay, done po. So thank you very much. Now for our closing remarks, first is we will call on our Vice President for Technical Affairs and our Overseer for the TCPDC, Sir Feliciano Padua III. Ayan, kayo na po, sir.
Hello, good afternoon again. Kanina nag-talk na ako, kaya magpapasalamat ulit ako sa mga participants na nandito. Sana po suportahan niyo lahat po yung ating mga activities ng IIE, either national o chapter. So salamat din sa mga panelists, sa mga speakers natin. Ang gagaling, maganda yung discussion at parang hindi kasa yung isang araw. Kaso Independence Day ngayon, malaking sakripisyo po sa inyong lahat, mga speakers na magagaling at tapos itong ating mga member ng TCPDC, sila Yas. Nandito rin yung mga officers. So tawagin ko na lang, mag-message si National President Alan. Nandito na siya. Pres Alan.
Yeah, PPTech. Thanks. Okay. Magandang hapon sa lahat. Yeah. Oh. So level up na ang TCPDC. Congratulations to you. No? This is a free webinar for the Independence Day. Talagang napaka-talaga ng tatlong topics for today provided by our speaker. No? Of course, Pres Charles Singson, si Sir Jesse Santos, tsaka si Sir Conrad Binondo. No? Timely in a sense na we have actually would focus doon sa ating potential na maging PEC3 in the future, no? Pero hindi mo na PEC3 ang itatawag doon ng ating PRC, BE. It's more of a guidance, no? It's electrical maintenance, inspection, installation, parang gano'n ang magiging guidance na we will try to create. No? And I think yung mga naging discussion point dito would be a good input. Then at the same time, for this month of June, we would be starting yung ating tinatawag na Practitioners Night. No? I know medyo kulang or bitin yung naging discussion point dito, ang dami pang questions. But with that platform, yung ating Practitioners Night, which we will be starting this month, no? Ang concept nito is like a 2-hour session. Perhaps our facilitator, which is an expert to the field, will have 30 minutes to 1 hour presentation of a certain topic. Then ang mga audience niya doon is yung mga mga members natin na who has the same line of expertise or the same field, no? Kaya pagka nag-invite kami, we'll be looking at the portal doon sa may specialization field na nakalagay, no? Ibig sabihin nun, ano yung naging trabaho nyo or mga previous experiences, ilagay nyo lang doon. No? Para when we try to sort out, then we will know the targeted participant for that practitioner's night. So hopefully, sila Press Charles, si Sir Jesse, Sir Conrad will provide their time. No? Parang ang concept nito, isang araw lang naman ang kailangan namin sa inyo for a month and 2 hours. So parang, for example, meron na kasi tayong ila-launch sa June 26, no? This is more on the power plant operation and maintenance. So every last Saturday of the month, yun ang magiging topic, no? 7 to 9. And then we'll look for other experts, no? Sa iba-ibang araw. Okay? Then lastly, again, narito si Engineer Charles, no? Our former president from Metro South. Yung ating ID kasi, yung universal ID natin, we would like it to be a value card already. Eh, siyempre, medyo may SM connection to. Sir Charles, baka pwede, Kasi si Gob Alvin will look into the other, siya tutulong din. So we have started it already here in Dubai. May at least 3 companies na that will be localized na mapapakinabangan ng mga members natin dito. But of course, in the Philippines, we would like to have that yung wide coverage ng entire membership natin. So again, CPDC, congratulations to you. A lot of CPD points, if we will look into the parameters, ng ating CPD for the year. Siguro nasa na tayo, including yung mga chapters, nasa around 80 CPD seminars na siguro tayo for the year. So again, congratulations everyone. Thank you.
Okay, thank you very much, Sir Alan. And also,
Thank you, Press Dubai. Namimiss ka na namin. Kailan uwi mo?
yeah, also, Sir Lyndon is with us. He has some announcements po. And hi, Sir Lyndon.
Yeah, good afternoon to all.
Closing na rin siya. At saka
Yes,
announcement.
naka-quote na po si Sir Lyndon.
So, kahit mainit. Okay, so actually we already have the preparation for to standardize yung ating mga codes, no? Actually, tama yung nababanggit kanina, we don't have what we call Philippine standards. But we try as an organization to find ways of crafting up a one code for the Philippines. Nabanggit kanina, we have the Philippine National Standards, yun yung under ng DTI. We have our PEC, in which it was discussed by Sir Jesus Santos, na yun ang nagiging basis nila for the PAR code. And another, after several years of doing the PEC2, it might be coming out this year, hopefully. Ang ating resolution or the resolution ng board ay nasa PRC na, waiting for the final signature of the commissioner of the PRC. And also taking note of what our president mentioned, yung safety installation and maintenance guidelines. It's supposed to be parang PEC3, but because of the instruction of our good Honorable Francis Mapillen, Jaime Mendoza, we would create for a while yung tinatawag nating guidelines for these endeavors. Now, for the hospital facilities, we have already these guidelines. Siguro we just clean it up muna yung preparation kasi nando pa siya sa point wherein we are waiting for other discipline to complete their own guidelines para yung hospital facility guidelines will be incorporated by all discipline, in which ang pinakauna pong gumawa nun ay tayo po in electrical engineering, in electrical practice. Also, part of this activity, you will start now collecting all your certificates and trainings that you've been attended. Kasi mag-start na rin po yung tinatawag nating career progression. So yung career progression is underway na rin, and the the IIE along with the PRC is preparing for these guidelines, especially on the competencies and the job job activity of every electrical practitioners. And lastly, although this is a pre-seminar with the CPD points, meron tayong bisita kanina kaya po alam nila kung paano tayo nag-start ng ating meeting, paano tayo nagkakandak ng meeting and other. Kaya yung napansin ko kanina na may nag-question na anonymous, mahirap po sa atin na makita ko sino si anonymous. Kaya it's better next time if you would like to ask questions, better to inform your names and be recorded as part of this activity kasi pag ito na-release yung ating database, baka yung pangalan nyo po doon is not properly given the true name. So magiging anonymous po yung laman kaya hindi po namin kayo mabibigyan ng CPT points. And to finally end this activity, of course, we would like to commend the group, especially the speakers. Talagang ganda ng topic and we try as organization na lahat ng ating seminar ay talagang congruent dun sa mga topic concern. And dun sa mga nag-inform sa amin na mag-provide din ng mga topics about solar, about energy and others, ito po ay pipilitin ng ating committee spearheaded by our overseer, Engineer Jojo Padua III, para mas maging maganda po yung ating outcome at talagang hanggat maaari ay hindi binibitiwan ng mga participants na hanggang ngayon ay malaki pa rin yung nasa session. It's almost 800 pa. So with that, maraming salamat and we'll see each other sa iba pang mga occasion like this. Thank you very much and good afternoon.
So there you have it, ladies and gentlemen. Thank you very much to our national officers, to our committee, to our panelists, and also to our delegates for supporting this activity. That concludes our program for today. This has been Yasmin, and see you on our next activities.
Yes.
Thank you very
Picture,
much.
Yes.
Picture.
May
Yes,
pahabol
sir.
si Sir Elboy. Paki-unmute ka, baka
Okay,
may
sir.
announcement siya.
Yes, sir. Sir Elboy, you may unmute na po,
Congratulations
sir.
sa TCPD. Congratulations sa inyo. Ang napaka-daming attendees nyo ngayon, 900 plus, nakita ko. Sana keep it up. Napakagagaling ng mga members ng TCPD headed by our chairman, Jodax. Napakagaling ni Jodax. Ang daming napapa-attend. Salamat po sa inyong lahat. At sana ay supportahan natin ang IIE at atinan natin lahat ng mga webinars. Sana ay marami tayong learnings na makuha. Ang ganda po ng topic ngayong gabi hapon na to. Ngayong hapon, tanghali. Maghapon kasi, ang ganda ng earthing, yung grounding. Hindi lang pala si Sir Jimmy ang magaling sa grounding. Marami talagang magaling sa grounding ngayon. Salamat. Sa mga speaker, magagaling po. Salamat. Thank you very much and God bless us all.
Okay, to our panelists, kindly open po your camera for our photo op. Okay, Sir Orlando Villapanya, Sir Sandro Villarosa, Sir Julius Salacop, yung nag-assist po sa amin to contact the speakers. Thank you very much, Sir Julius. Sir Jonathan, Sir Jun Herrera.
Thank you.
Ayun,
Thank you.
open po natin yung mga camera natin para po makapag-photo op po tayo. Sir Noel, Sir Jonathan. Okay, smile. 1, 2, 3. Okay. Baka may hahabol pa po na makakapag-open ng camera. Sir Orlando, Sir Julius, Sir Noel.
Thank you.
Yes,
Okay lang.
one more smile. Okay, thank you very much and thank you also sa mga delegates.
Maraming salamat.
Thank you.
Thank you.
Thank you.
Thank you, Yasmin.
Thank you, Charles.
Thank you po.
Thank you, Sir Conrad.
Thank you, Yasmin.
Julius, thank you, Julius.
Thank you. Happy Independence Day to all. Senior Conrad.
Thank you. Bye-bye.
Mabuhay ang
Bye-bye.
Pilipinas.
Bye.
Thank you, sir. Thank you. Kakanta yata si Yasmin.
Wala tong fellowship night.
Pres Alan, Metro Central may fellowship sila. Fellowship night.
Meron daw pero parang private na yung fellowship nila.
Meron?